This is going to be perfect for mission-critical workloads. Today, Ivan will walk us through YBD's game-changing features, from handling complex data-driven applications to its seamless deployment options. So please join me in welcoming Ivan.
Thank you. Hi, everyone. Yes, my name is Ivan Blenkov, and I was introduced already. So let's jump into it. Today's talk will consist of three main parts. First, we'll explore what's YDB and what it can do in main use cases. Then we'll see high-level architecture around how it works and what to expect from it. Then we'll take a closer look at a couple of interesting technical details. And finally, we'll see how YDB fits into broader overall open source ecosystem. So as the talk title says, YDB is an open source distributed SQL database. It's designed for business critical applications that have really strict requirements on both data consistency and availability. To accommodate this, YDB provides distributed transactions that provide serializable isolation level by default, which is stricter than most other DBMS do. And also it automatically survives hardware issues, even major ones like the whole data center is going down, while maybe you have a maintenance in some other one, or also one rack, another data center is also unavailable. Initially, YDB started as transactional database, but over the years, it grew to be more like data platform with a bunch of extra features like column-related tables for analytics, topics similar to Apache Kafka topics, federated queries, and so on. On the slide, you can see typical industries that use YDB, and also a bunch of user logos that you likely won't recognize because they're from different parts of the world. But the point here is that these kind of requirements usually come from two things. It's either directly managing business data, so like financial transactions, orders in e-commerce, taxi rides, clicks on advertisements, and so on. So when you have direct impact of your data unavailability or outages to your business and your revenues, or by second option is if you provide low-level infrastructure for other businesses to rely on with similar consequences. On the slide, you can see key milestones in YDB's history, but the key takeaway here is that YDB is a pretty mature technology with well over a decade of development invested into it. But it's only 2 years in open source under Apache 2.0 license, which is one of the most permissive open source licenses, allowing even commercial use for free. And we'll briefly touch other topics later in the talk. So how YDB works? First of all, to accommodate these kind of requirements, it normally is running on a cluster. And in most cases, these clusters span multiple data centers to accommodate these kind of outages. YDB clusters consist of two main nodes, compute nodes highlighted in blue, and storage nodes in purple. Let's quickly walk how a typical SQL query path works. So this cluster provides for outside world a few like common APIs. So on the slide you can see the YDB native one. It is based on gRPC, which is a common cross-service communication library that provides code generation for both clients and servers. And for clients, we also provide SDKs that basically wrap these generated clients to add some features that are useful for applications talking to databases like proper read-writes of transactions, load balancing, and so on. So once the request comes to the cluster, to the proxy component, it gets passed to the query processor, which is a kind of orchestrator of the whole query execution. So it, in a distributed fashion, it understands which other components need to be involved to produce the requested result. Often, it needs to execute a distributed transaction with a separate mechanism we will quickly return to later. And most of YDB features are implemented in a framework we built that we call tablets. So a tablet is a lightweight user space process so you can have much more tablets in a system that you could have operating system threads. And these tablets talk to each other only via message passing. This is similar to actors you can find in Erlang, Akka, and similar technologies. And each tablet has its own private state that it stores on reliable distributed storage. So also with all this redundancy. So and basically distributed storage is specialized, so it's not some external third-party thing. It's a specialized system that's designed specifically to store tablet states. And also fun fact, it stores data not on file system of sorts, but it directly works with disk drives via block devices and tries to leverage their physical properties to do it efficiently. So that's the second part. We'll take a closer look later. So, and this design allows these tablets to easily move between nodes because you can kind of always restore its state from remote storage. And this allows for two main things. First, it allows you to restart this failed process on another node in case of any failure. So if some issue with the node, you can easily continue processing what you are doing somewhere else. And also for load balancing, because if some node is overloaded, again, you can free it up by moving some tablets from it. So all VDB features are, not all, but most VDB features are implemented as tablets. For example, there are tablets responsible for subsets of rows of row-oriented tables. There are tablets that are implementing partitioning of topics. They're similar to Apache Kafka topics. But each instance of tablet is managing only a small subset of data. So this kind of logical entity of a table or a topic is what people are working with, but they don't see these implementation details. And that's what allows them to kind of easily work with large amounts of data that automatically adjusts to whatever environment is currently happening in the cluster. So let's take a closer look at the distributed storage layer. So it provides two main operating modes. I was mostly talking before about the left one, Mirror3DC. So it's a cross-cluster mode that provides the most resilience in terms of fault tolerance. But because it's basically copies of data, so replicas, it provides 3 times space amplification. So you need 3 times more disk storage, disk capacity to store each logical piece of data. And also VDB has alternative kind of compromise mode called Block 4.2. It's designed for single data center operation, but with still reasonable level of fault tolerance, so you can survive 2 server racks going down and still continue operating, accessing your data as if nothing happened. And there are a couple more reasons you might choose this right one. So first, it's less space qualification, so it needs only 50% more disk capacity compared to the logical data. And second is this distributed transaction, they require multiple network hops to execute, and inside single data center, it leads to lower latencies of transactions than comparing to going between data center for each transaction. Let's see how Mirror3DC works, the first topology. So you can see we have 3 data centers and 3 nodes in each data center, ideally in separate server racks. So this kind of minimal setup that makes sense, and we'll see why in the next slides. And to explore how this works, we'll use write operations as an example. So in normal case, when everything is working fine, it's simple. You choose 1 node in each data center and write a copy of data to it. You've got 3 copies. And you can survive these requirements of going, these requirements of availability. So, but the interesting thing starts to happen when failures start happening. So if you have large enough cluster, you might have disk failures and node failures happening daily, and full data center outages are also not something unheard of. So in this case, let's imagine we have a fire in data center 2. It's hard to see now, but and maybe you have maintenance going on node 7. So in this case, we need to write 4 copies of data to continue maintaining these guarantees of surviving this kind of outages. Anyone has idea why 4? No? It's to continue accommodating multiple failures like this going one after another. So let's imagine this previous failure was resolved somehow, and immediately or shortly after it, another similar one happens in different data center and different another node. So if you wrote on the previous slide only to 3 copies, you might get unlucky, and the 3rd copy would end up on node 4. and you will lose read access to your data. But in this example, node 1 is kind of surviving one from the previous write that will still allow you to read back whatever you originally wrote. And then similarly, after this new failure happened, or new write operations will still be able to find 4 more nodes to continue doing the same thing over and over, and thus always providing you access to your data no matter what, like as long as you stay in inside this failure module. So a single data center block for 2 works similarly, but it uses a different approach. So instead of copies, copies of data, it uses an approach called erasure coding. So basically, it's an approach when you kind of create 6 parts out of your original piece of data. It's 4 data parts and 2 parity parts. And there is a bunch of math that's based on Galois fields, if anyone into it, that allows you to restore the original piece of data from any 4 parts out of 6. Basically, this allows you to lose any 2 server racks and still get access to your originally written data. And if you were wondering why 8 nodes and not 6, it's because you still want to continue having 6 separate server racks to write new 6 parts, even if the outage is happening right now. The second technical highlight I want to give is transactions. So distributed storage we just explored is providing reliable storage of state of each tablet. And from the user perspective, you'd want to have transactions not inside one single row, but between rows of single tables and between different tables, between topics and tables, and so on. So you need transactions that are kind of global, involving multiple tablets at the same time. So that's why we have separate mechanism for doing this. And also, Webby provides more strict guarantees than many other databases for this, called serializable isolation. So the initial implementation of these transactions were based on this research paper that's cited in the bottom. The paper is called Kelvin, and it's from Yale University. And it introduced an algorithm that's called deterministic transactions. It's in nature similar to Raft and Paxos that are more widely known. But in general, it fitted better the requirements of what we had at the time. But there's one big downside, that it limits what kind of transactions can be executed using this approach. So for instance, it requires you to know in advance which subsets of keys or table rows will be part of transactions before you start executing it. And in real-world scenarios, that not always viable to know this in advance. For example, you might have secondary index that you use to resolve which keys you need to read from the main table, and thus you figure out the keys along the way. So initially, we had this requirement exposed to end users, but over time, we built these 2 extra mechanisms, optimistic locking and VCC, to allow a wider range of user-level transactions that basically use deterministic transactions as a building block to execute multiple of them and still check that everything is correct as user requested. So check the paper if you're interested. And the last part is about YDB in open source. So when the project was originally open sourced, it already had its own ecosystem, which also was open sourced SDKs and integrations and so on. But one of the first things users requested was integrations with other ecosystems. That's why we invested into PostgreSQL compatibility mode and Apache Kafka compatibility mode. And similarly, historically, it was mostly deployed using proprietary deployment tools, but now we're working actively on basically we have Kubernetes separator and Ansible playbooks to deploy with more widely used approaches globally. Same goes for integrations with observability and data management. So these are just examples of technologies we integrate with. I have only a minute to cover this, how Postgres compatibility mode works. So basically, we take clients from PostgreSQL ecosystem because we want to be compatible with them. We had to re-implement PostgreSQL wire protocol because the original implementation is kind of weird because it forks operating system process for each client connection, which is resource intensive and doesn't scale. We took the components that implement most of semantics of how SQL queries are executed from Postgres, but reused all our infrastructure with tablets and storage and transactions to provide all these properties people care about when they choose UIDB. To wrap things up, we are looking for contributors. So the core platform is built from scratch in C++. We have Kubernetes separator, Ansible playbooks, SDKs in all major programming languages, documentation Markdown. If you're into stuff like this, please go check it out on GitHub with QR code. Or you can find us as YDB platform. That's it. If you have any questions, you can find me upstairs. We have a booth there. Or you can connect with me on LinkedIn. My name is Ivan Blenkov. Thank you.
Any questions?
Yeah, that was a nice talk. I wanted to ask you more about the Apache Kafka compatibility that YDB has. What does that mean?
Yeah, basically YDB has its own API that's kind of similar to what Apache Kafka has. It's also based on gRPC, and it was designed to make it easier to provide exactly one guarantees, which is kind of important in this space. So you don't have duplicates or lost messages. So yeah, but again, like one of the first things in open source that people request were kind of compatibility with client libraries that they are used to. So basically we have another API that takes a wire protocol that Kafka's client libraries expect and implement the same server side for it, and then translates roughly to the same execution path the YDB topics infrastructure expect, and it looks closely similar. Yeah, that's kind of what it is. It's CP. The question is what part of CAP theorem is it reliant on? And basically it gets the closest to CP part of it. Yes. So we use optimistic locking and multi-version concurrency control. So it looks similar to what you would expect from other databases like Postgres and others.
Hello. 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 Am I audible? Yeah. So you mentioned that that you need to write to at least 4, where the other node is in a different data center, right? In your 3 data center architecture. So when the 2 nodes that were down before come back up, you're going to replicate to those 2 again when it's up?
Because you have time to do that, and failures might happen frequently enough, so kind of you're unlucky.
So in case if your reads come in before the replication happens, how do you decide which node to send the reads to?
If all reads, well, actually it's a little bit more complicated because there are multiple modes of reads, and these tablets can decide what read mode to use. And actually, for example, they might read all copies just to take the minimal viable amount to produce faster, to get the fastest responses, and also they can go slower if they care about overall throughput rather than latency of each particular read. So it's kind of depends on business logic on top of it, like on higher levels, on how to handle this.
Thank you.
Hi, I had a small doubt about the database thing. So do we have to have a separate special configuration to set this distribution up, or does it happen natively? And also, when you do a write operation, let's say some kind of a locking write. So I'll just repeat my question. So to configure this, do you have to specially configure anything on each node level? and let's say you have a write, like a locking write, so how will it handle across each and every worker? So will it be locking all the workers at the same time, or how does it work?
This locking, it works not on workers. It basically checks correctness of the overall transaction. So it works not on workers. It works on ranges of table keys, like because they're all kind of ordered by primary key. Yeah, and that's for configuring each node. So obviously there might be some operating system configurations you might want to make just to make performance better. But in general, the trickiest part here is that nuance I mentioned about working with raw devices. For example, I had another talk a few weeks ago in Hong Kong about how to pass block devices from your host machines to Kubernetes. They have like 5 ways to do it with different trade-offs. Yeah, so obviously there are some nuances around it, but in general, all this sharding and something basically boils down to choosing which of these topologies you actually care about. So they're kind of the main one we recommend. And it's cluster like administrator, DevOps, whatever you call him, needs to choose like which kind of way you want to go depending on how much hardware you have, how much space and latency requirements you have. So that's kind of the main thing. And after this, it's like nothing way too special. So basically all sharding is happening automatically. So from application standpoint, you're just working with a petabyte size table, and it somehow load balances, self-heals if something happens. So it's not application developers' problem to how all this happens.
And as you just mentioned, your isolation level is by default serializable, right?
Yes.
So it will be, yeah, that's where you said optimistic locking. So it's going to lock before it does any kind of conflicting right?
No, actually optimistic means the latter. So basically it checks on commit that everything is still okay. And there are trade-offs around this. So you might like hope that it happens, but so it's like with pessimistic, optimistic, like in normal life. You might hope that it will happen, but you'll be not so good surprise in the end. Or you might be pessimistic in the beginning and not even try. So depending on the workload, it has some performance properties, and you might need to retry if you ended up. So there's specific error code that says, hey, you need to retry this. And you might see it in this approach, but it happens on commit and not on first of operation. So it's different from some other DBMS that do pessimistic locking.
Thanks for resolving the query. Thank you.
Thank you. I think we're out of time. Thanks again.
Thank you for that talk, Ivan. So up next, we have Mr. Gautamraj Irango, an engineer turned social sector professional with 7 years of experience in using tech in driving social change. As the head of technology at Reap Benefits Foundation, he has been leveraging open source tools like Samaaja to empower communities and create impact at scale. Discover how FOSS drives large-scale impact and learn about the Jaldoot program's success in Assam, where Samaj enabled 17,000 plus Jaldoots to survey 5,000 villages using low-code technology. Please give him a warm welcome.
Good morning. Am I audible? Just give us a couple of minutes. Okay, in the meantime, since my introduction is already done, let me actually start with my own personal story, how I first encountered with free and open source software. Let me take you 15 years before I was in college. I don't know how many of you know this. There is an open source operating system called as Ubuntu. This is back in 2008 and 9. During that time, they do free shipping program. So you make a request, and it will be delivered to your own house. So me being someone from a tier 3 town receiving a package with a CD from Netherlands itself is a great motivator to get started. Without thinking anything, just open the package. There was one CD, started installation. I mean, of course, it was challenging. There are a lot of failures. I messed up some of the very important files my father was having on his system. All those things were happening. Back then, it feels like it's a very complex and a very vast thing to handle. But some of the principles I was able to extrapolate is the transparency, the openness, the collaboration, and more importantly, the shared vision to solve a real world problem. Why an open source software exists, why Ubuntu came into existence, had a longer and deeper impact within me. Then those principles are something that I have always carried forward 15 years after, still in whatever the work I do, whatever the principles, wherever I go. That is something that I strongly hold on to. So in today's talk, I'll be covering 3 parts. One, a little bit context about the work I do, the organization where I work, because that is important. Second, the free and open source software that we have developed in support of FOSS United, the why of it rather than what it does. And then, okay, the software is great. Does it lead to any on-ground impact? So I'll also present a small case study, and of course, happy to take questions after that. Great. Samaaja, FOSS for citizen engagement. What does the specific use case, the case study I'm going to talk about is how FOSS or Samaaja has led to engaging and incentivizing youth at scale that lead to an impact, which we will be covering in the upcoming slides. So I work in a not-for-profit called Reap Benefit. What is our goal? Our goal is to foster agency in youth. How do we do it? By activation of 21st century skills. How do we activate 21st century skills? While there are different ways, the approach we take is by making them solve on-ground, local, civic, and climate-related problems. What does it lead to? The hope is that it will lead to resilient communities. Great. How do we do it? On theory works fine, but can you explain a little bit more? What do? We activate youth agency. How do we do it? By enabling them to take actions and consistent actions. When someone takes actions, what is that individual output or impact that they are creating is the activation of 21st century skills. When these young people as a group or collective start taking actions on the ground, it generates 2 types of informations, which is one, it generates 2 types of informations. One, the bottom-up or on-ground civic and climate-related issues. It can be a problem that they have discovered, or it can also be about an investigation that they have done to know more about the problem. Okay, the problem is discovered. Some form of an investigation is also there. The second type of information that is getting generated is how can, as a individual or a community member, I will be able to solve those issues, which means the community solutions. So as a second output, we generate public goods, which is a crowdsourced data, and the local citizen-driven solutions. So before that, okay, this is the theory of change or the social change model. At the bottom, as you can see, we have the Solve Ninja tech platform. So here tech is an enabler. What do I mean by tech as an enabler? Can all this impact be created without technology? The answer is yes. But can that be enabled in scale? Can we do it in scale? That's a question, right? So now what is this Solve Ninja technology platform? So that's Samaaja. So Samaaja, literally it means society. It's a free and open source software created for location-based citizen engagement. And it was created in collaboration with FOSS United and ReBenefit together to allow any organizations to leverage Samaaja in their work to mobilize citizens on the ground. What led to the creation of Samaaja? In our citizen engagement work, 3 major issues ReBenefits was facing. One, how do we meaningfully acknowledge and incentivize or create value for our stakeholders? In our case, it's the youth. That's the problem number 1. Second, how do we create a space of gamification where there is collaboration over competition? Third, we generate a lot of geolocation information from the ground. How do we use this information to create meaning out of it? How can we use this information to provide actionables to the community? So 3 major problem statements. With this, we reached out to the FOSS United team. At that point, we wanted to have a specific solutions that work for ReBenefit. But again, going with the FOSS learnings, instead of creating something specific, how about we create something generic? Because this seems to be a common problem with a shared vision that needs to be solved with different organizations across India working in this sector. So that's how Samaaja was created as a free and open source software. How does that, how Samaaja solves these issues? It is low code, it's faster, it's easy and simpler to deploy it. It has built-in configurable user profiles. By default, you will get a configurable badging system. It also comes along with a gamified leaderboard. It also comes along with a system to easily manage the geolocation information. And finally, it provides the ease of integration with the existing platforms. Okay, sounds good. Does it really, like once we have a platform like this, will it lead to immediate impact? As you can see, that is one simple example of Samaaja in action. As you can see, just to give context, we used Samaaja as a platform to crowdsource bottom-up citizen information regarding dengue. Like there is a lot of dengue cases here. We wanted to crowdsource that information. How did we do that? As you can see, because of the possibility and ease of integration we're using Samaaja, the user-facing platform is a WhatsApp chatbot, which is powered by Glyphic, which is also an open source. The users provide the information, and then the data that is getting generated through the user added to the Samaaja database, and then it starts populating as on a map, which will start giving community insights or actionables to the community. At an individual level, these are actions which leads to skill development. By contributing to the crowdsourced information, the user's profile will be auto-created by Samaaja. And as you can see, the skills. And these are configurable. What you see is in the context of ReBenefit work. So great, the tool is there. Will just using this tool can we create an impact? The answer is no. It has to be a mix of technology plus what are those levers that make that shift, right? What are the key levers? Based on our 10 years of work, the 5 major levers that enable change on the ground, or behavioral shift or mindset shift, are network of local mentors. This is general to all the work, whatever the context you want to put in, you will be able to relate to. Access to peer community, access to knowledge and solutions that works on ground. These are bottom-up solutions, but of local solutions, but with shift in context, this can be replicated across. Access to technology. This under technology, it can also be access to data, access to information, And then finally, consistent behavioral nudges. The key is this: how do we make people to consistently take action so that it leads to a permanent change? Great. All sounds good. Can you really show me an impact that Samaaja has created? Is there a realistic use case? Yes. So let me explain you about the recent collaboration that we had with Jal Jeevan Mission. For those who don't know what is Jal Jeevan Mission, it's a government initiative to ensure safe drinking water in every household across India. Jal Jeevan Mission of Assam reached out. They wanted to, in Assam there is this problem of about half of the population does not have access to safe drinking water, which is actually leading to 2 lakh annual deaths based on a recent report. Assam is a flood zone. But the sad thing is there is a lot of underground contamination happening, so you can't immediately take that water and consume it. Okay, the problem is clear. Are there solutions? Yes, there are solutions. That's where the Jal Jeevan Mission comes into play. But low awareness about the Jal Jeevan Mission. The youth are not engaged, so there is a lot of defense from the community in whatever being proposed. There is a need for behavioral shift. So this is the problem, this is the challenge. And with that, we wanted to create, what is the aspiration? The aspiration is to build the first mile water champions in each and every village of the Assam. So that's the goal with which this project was initiated. Reap Benefit is one of the partners, and then Jal Jeevan Mission Assam. Then we have INREM, who are the water experts. So we came together and then put out this program called the Jaldut. So Reap Benefit was focusing on our own strengths, which is enabling online and grassroots mobilization of youth through technology. INREM was playing to their own strength of water management and water expertise. Of course, the other pieces are the government departments which were playing the orchestrators or facilitators on the ground. How does this journey look like? Jaldut is a grade 7, 8 or grade 9 student selected from the rural schools of Assam. They go through a 2-day sensitization program where they know about the water supply scheme or how the water treatment is being done. Then they are onboarded to the technology. In this case, the call to action is after this 2-day session is over, go back home, give a missed call. When they give a missed call, they'll be onboarded to the WhatsApp chatbot. And then through the chatbot, there is a consistent engagement happens in form of nudges. And the example of nudges is, can you do a survey of your water supply scheme? Can you participate in this challenge of crowdsourcing? Do you want to create awareness about water supply scheme as a campaign in your locality? So these are nudges that are sent out to these Jalduts. The consistent engagement lead to the creation of offline and online communities created at a local level, at a village level, or at a cluster level. And now it's been 8 months since we are working with Jal Jeevan Mission. Now we have a community of 40 active young people in Assam who wants to drive change beyond water as well. What is the overall impact look like? 24,000 Jalduts activated. 5,000 villages are there, which means 5,000 schemes are survived. 2,000 plus data points have been crowdsourced. More than 14,200 problems problem-solving actions been taken. 100 effective change makers have been identified, and we have the first community of 40 active community leaders. Great. Now, can you show me how does Samaaja helped in this entire process, right? On-ground action leading to behavioral change. How does it happen? The bot being the user-facing platform, we sent out nudges to them in their local language, which enabled sustained engagement. And on the right, you see is the leaderboard, which is powered by Samaaja, which gives the sense of a peer community and creates this gamification aspect of collaboration, inspiration over competition. People on the top got this sense of accountability that they wanted to share. It actually created that spirit of collaboration, openness, and transparency within the community itself. On-ground action leading to skill development. So what is the takeaway for the young person, right? For them to just go on the ground, because we are asking them to solve a real world problem. And it is not a cool thing to do. Like if a young person choose to, I want to go and play with my friends, versus I wanted to go and solve a problem on the ground, the eventual mentality is this, right? So what are those incentives and rewards that we can show them so that they start to see the real value of it? So what you see is a user profile customized for Reap Benefits and Jaldoot's context, powered by Samaaja. So any action the young person is taken, which is reported and captured through the bot, is mapped against that skill metrics that we have, which will show them what are the skills that gets activated, the skills that they are good at. The eventual aspiration for this platform is how do this changemaker portfolio democratize the way currently people access to opportunities. Just because someone does not know how to articulate better, does not know English better, might miss out having access to these opportunities. So the idea is, can skills, can facts lead to access to opportunities? On-ground action leading to activation of youth agency, data getting generated, made public, open data. What you see is a community-driven insights. They use this data to hold the local governance accountable. And finally, 3 months before, the entire program had a massive impact in terms of the way the water supply scheme is getting implemented. Now the Jaldoot program is a national policy. This means any state which wanted to work with youth around water conservation, the highly recommended program is Jaldoot. Yeah, that's about the impact of the entire program of Jaldoot program, which was empowered and enabled through Samaaja plus the levers. The key is not the technology, the key is not just the levers, it's the combination of the both. Okay, coming to the technical aspects, it is created using Frappe. It is ready like Frappe framework. So every detail is available on the GitHub. So you can download, all the documentations are there. So the ways to get involved, what are the different ways one can get involved? One, definitely there is support with the adoption, as in there is a lot of not-for-profits who wanted to leverage Samaaja, but there is a tech capacity and tech understanding gap. So it's a very niche opportunity that technologist has at this point to work with these not-for-profits and then empower them. That said, if you are interested in exploring this, how do I contribute to FOSS for social impact? We have a booth called Oasis. So Reap Benefit is also a part of this alliance called Oasis. The idea is, how do we bridge this gap of tech understanding? How do we, in not-for-profits, how do we help not-for-profits to leverage open source? So that is definitely a potential area of contribution. Second, coding contributions. Of course, you are welcome. Every detail, and we have a set of problem statements and wish list already there for Samaaja 2.0. You can definitely chip in and contribute. Documentation, we have a decent documentation created, but would love to have a better documentation setup. Community setup is mostly around the adoption part, like being a part of an Oasis will actually help in terms of supporting NGOs, at the same time hand-holding NGOs in deciding what type of technology that they can leverage. Mentorship, if you're good in Frappe, if you wanted to support because there is a lot of interest in our tech community that Reap Benefit has, and especially in the Oasis booth also, there is a common trend we are seeing. They are interested, but they don't know where to start, and we don't have the enough capacity as well to provide that mentorship support. So if you're interested, if you wanted to groom others, definitely that is another area you can collaborate with. No more. So the website links, GitHub, what is the default design of the leaderboard, default design of the user profile, the tech documentation, the tech installation script, all these links are here. Thank you. Happy to take any questions if there is time.
We can take questions if you have any.
Hello, good morning.
Yeah.
Yeah. How can we use open source like Samaaja for gathering various type of city level data like geolocations, amenities, etc., etc.? Could you please elaborate?
Great. By default, Samaaja has the ability to handle the location information. When you say location, latitude, longitude, and maybe a small description. It has all the necessary schemas and systems readily available. That is one from an infrastructure point of view. Second, the possibility that Samaaja create is the ease of integration. How we have used WhatsApp as a primary source to collect this information, like that we can use forms, right? Let's say I have already the data which is available, but I just wanted to ingest it. There is a backend process through which we will be able to do that. So one, definitely integrations. Second, there is the by default forms can be created through Samaaja where people can fill in. Three, if you already have the data, there is a system, very simple system to ingest the information in the backend.
Thank you.
Just to add on, we have a collective called Samaj Data Collective. The idea is exactly this. How there is no single place where all hyperlocal information is available. So we are getting information which is available in clusters in different places in one place, and then trying to see the intersectionality. For example, the recent dengue initiative talks about dengue hotspots and it's relevant to rainfall and temperature increase. So how do we bring these together and show it as a narrative to people so that the conversation kickstarts? So happy to discuss or explain further. Yeah. Any more questions? Okay, thank you. Just in case if you want to explore this further, at 11 we have a Birds of Feather session in Auditorium 3. It is about FOSS and social impact. I mean, it's an invitation, open invitation for those who is interested. Feel free to come there. Thank you.
Thank you, Gautam Raj, for not only explaining the what, but also the why and how of Samaaja. Next, we have Rohini Lakshane, a technologist and an interdisciplinary researcher for a passion for intersection of technology, policy, and civil liberties. With a background in engineering and extensive experience in research and advocacy, has made significant contributions to understanding the complexities of technology and law. Today, she'll be shedding light on the intricate relationship between standard essential patents and free and open source software. So please join me on welcoming Rohini Lakshane to the stage.
Good morning, everyone. Can you all hear me? And thank you, IndiaFOSS, for having me over. Yeah, so beginning with a disclaimer, I'm not a lawyer, and none of what I'm going to say today amounts to, qualifies as legal advice. This talk assumes basic to no knowledge of patents. If there are experts in the room, please bear with me. And it's a dense topic, so and we have about half an hour. So if you'd like to discuss this with me after the session, please feel free to do so. So a little bit about my own context and background in this. I used to work at the Center for Internet and Society in Bangalore, where we did the first ever landscape of mobile phone patents in India back in 2015, and the study was published in 2017. In addition, I published a paper on the ongoing big ticket patent litigation in India, where Ericsson and another company in different cases sued different Indian mobile phone manufacturers for infringement of their standard essential patents. So the first ever patent landscaping exercise for mobile phone patents in India that I just referred to was with Professor Jorge Contreras at the University of Utah, and we found about 300 granted patents and almost 10 times as many patent applications in that particular data set. The data set is publicly available. We did not count how many of those were standard essential patents. Now, the implications of finding granted software patents, I'll come to in a later slide. But why is this talk happening? Like, why are patents relevant to this community? One potential reason is that individual FOSS dev or volunteer-run projects, they stand the risk of patent infringement claims or lawsuits. Any other reason why patents are relevant to the people here? Okay. So standards essentially exist so that there is interoperability between different software, between different files, so that everything works, so that your entire infrastructure can talk to each other. That is why standards exist. Some standards are formal, which means that they are set by set in formal processes at standard development organizations, whereas some are de facto, which means that they evolve over, through market processes. What is a patent? It is one of the types of intellectual property, and its purpose is essentially, okay, I made a cool invention, but I may want to keep it to myself because I may fear that it is misused, or it is, somebody else may steal it. So this is meant to incentivize disclosing the invention, and in return, the inventor gets exclusive rights over the invention for a limited period of time. And for that, they may charge royalties using which they can recover their costs of research and development and so on. So that is the reason why patents exist. What are standard essential patents? Essentially, if a technical standard is to be implemented, then those patents come into play. Now, who decides this? The patent owner. There are formal processes where the patent owner self-declares that I own these patents that are essential to these standards. Now, in very complex products, such as in the study that I conducted, which was in the internet and telecom sector, a single standard may be covered by hundreds of patents. In the same way, there are many software standards that are very heavily patented. So once the standard essential patents have been established, anyone who wants to use the patent, an implementation of the standard means anyone who wants to use the standard in their software, they need a license from the patent owner. Now, licenses can be royalty-free, which means you don't have to pay anything for using those patents. Some are licensed on terms that are called FRAND, which means fair, reasonable, and non-discriminatory. Some are called RAND, which means reasonable and non-discriminatory. Now, this is very contentious because what is fair, what is reasonable, what is non-discriminatory according to one entity may not be so according to another entity. Now, a few slides ago, I said that software patents are not granted in India. What by not granted, I mean that a specific section of the Indian Patents Act, Section 3K, says that computer applications are excluded per se. And then there are guidelines of the Indian Patent Office regarding what are called CRIs, computer-related inventions. And the reasoning behind not for excluding software patents is that it is already protected by two other kinds of intellectual property. They are protected by copyright, and they are also protected by trade secret law. So patent protection for software is overkill. Now, what can happen if you get a claim or you get sued for infringing on somebody's patents? So you might get a cease and desist notice saying, hey, stop using them and pay me royalties, or I'll sue you, or you may get sued directly. Is that in response you may have to make drastic changes to your project, you may have to shut it down, you may have to remove features, you may have to pay up to use the patent, plus all the, the entire process of filing a lawsuit if you do go into a lawsuit, and the harm to your reputation, because you essentially get accused of stealing somebody else's intellectual property. Now this is not, what you see in the screenshot, is that readable? It is not. Okay. So this is about a plugin of the image editing software GIMP. This patent is not a standard essential patent, but this is a note from the developer's website who worked on the image mosaic plugin. The developer says Mr. Robert Silvers, the holder of a patent related to the technology that was used in the plugin, argued that the software would directly infringe his patent's rights. It is not clear if the patent is applicable in this case, but I have neither the time, interest, or money for legal action. So I complied with the cease and desist request. So you can see what happens here. The developer doesn't even know whether the patent applies and whether they can be sued there, but they don't have the resources or the bandwidth if this matter goes to court, and so they complied any which way. Any questions so far? Yes. Yeah.
Free. So are there licensing applied on the standard, or the patents required for that standard?
The licenses are for patents only. Whether or not it is royalty free, that this will be mentioned on the websites of the standards development organization, or they'll have a policy saying all. There are many organizations and many, processes, so they will state what are the terms of the license on their documentation.
So the standards per se are always royalty free, is it? Or like
So
license fee?
the standards will have corresponding patents, right? So those patents are royalty free or FRAND or RAND. Yeah. So the royalties are for patents. Yeah. Yeah.
Thanks.
Yes. So patents are jurisdiction specific for each jurisdiction, that is for each country. You have to apply in that particular patent, that country's particular patent office. So when you apply for a US patent, you're applying for a patent that you can use, sell, you can manufacture, you can provide a service in the US. If you want to do that in India, then you have to apply for a patent in India. Yeah, so some of the tensions between SEPs and FOSS. So how many have used OpenOffice or LibreOffice? Almost everybody here. If any of you works with complex formatting, text formatting in those documents, in docx, for example, you will find that if you're working with someone who uses Microsoft Office, the document becomes unusable. You can barely read it. So, I use LibreOffice, and I have to tell people that I work with that, okay, if you are using Microsoft Office, don't even bother, because I will not be able to read your docx. let's use something else. And that is because even though they are governed by the Open Office XML standard, what has essentially happened is that the standard itself was fragmented in a way that, the standard that works in that works in MS Office is different from the one that works in LibreOffice. So this is fragmentation, and this is causing interoperability issues. And like I said earlier, the main reason why standard exists is because we need interoperability between different different software. This is a very fundamental conflict in the sense that, as I said earlier, the point of patents is to grant exclusive rights. And therefore, the idea is exclusivity, but FOSS is promoting, open access to technology. SEPs are usually licensed on FRAND terms, fair, reasonable, and non-discriminatory. Non-discriminatory here would mean that if it is a standard essential patents, you don't like, the owner can't say, I will give it to this person, but not that, to this entity, but not that. And therefore, like, fundamentally, the terms for licensing can be incompatible with the licensing terms of FOSS projects, because FOSS is geared towards openness, whereas patents are geared towards exclusivity. And FOSS licenses often require that the entire source code be made public, and that it is distributed free of royalty. So this is quite a complex topic. We don't have enough time, but the fundamental conflict is the principles of these two things. So patent assertion is the screenshot that I just showed. Somebody saying that I own this patent. They may or may not implement it, which by implementation I mean that they may or may not sell a service or a product or perform some other activity using the patent. They may just be holding the patent. They may not even have invented it. They may have bought it from somebody else. So that is called patent assertion. Sometimes the term patent troll is used, although the entities that do it, of course, don't like the term. And like we've seen in that example in the screenshot, that they will say either stop using it or pay me royalties. But FOSS licenses don't require the making any payment. So this threatens the very idea of FOSS. Now, like I said previously, standard essential patents are self-declared, which means that the owner says, I have these bunch of patents, and they apply to this particular standards. Now, that is done through a formal process at standard setting organizations, standard development organizations. It's very difficult to determine how many of them are truly essential to the standards. And this goes into, how the language of the patent, which is drafted by patent attorneys, patent agents, and it is often geared towards not disclosing, which is the point of a patent is to disclose the invention, is geared not towards disclosing, but towards obfuscating, to make it harder to understand, make it harder for somebody else to read it and use it, and so on. And so the lack of this transparency, so patent owners clearly have an incentive to over-declare which patents are essential, and they often they often license an entire bundle of patents. So that may include expired patents and so on. So this lack of transparency, makes it harder for someone in the FOSS domain, say an individual developer or a small organization or a volunteer-run project, to determine whether they are in line with the requirements of patent licenses and whether they are on the right side of the law. So yeah, I if we can connect offline, I can share some of these reading material about how fundamentally software patents hurt the idea of free software. Thank you. Any questions?
Hi, I'm Shiv. My question, not exactly on the patent, but using patent, how we can secure the open source software, getting commercial in the futures, because so many organizations, even though it is uh, copyright or GPU, they are getting commercialized. For example, recently Oracle acquired, not recently but it's been long time, and again Talent recently. So many open source softwares are being acquired and making it commercial, but how patent can play a role to avoid such the acquisitions and making it commercial.
So as far as I know, mergers and acquisitions will have their own terms about what happens to different, like to the assets and property owned by the acquired company, right? So if there are usually clauses that will say that whoever, like that patent will get transferred as part of the acquisition contract. I don't see how filing a patent would change any of that, because the point of doing the acquisition is to get everything that is owned by the other entity.
Got it. But my question, is there any role patent can play there to stop that? Because a lot of developers are contributing to the community and the open source. And is there
So
any
exactly, the thing is that this is why software patents are not allowed. Is uh, you know patents are geared towards exclusivity, and if it's a collaborative effort, if it's a community effort, if it then it can't be land grabbed by one entity. This is exactly why software patents are not allowed. So the patents should not be allowed. So we need to fight them off, not like get more patents.
got it?
Yeah.
Like Open Invention Network, I think
Yes,
they
there is
offer.
one person from OIN here. Yeah, yeah, you can talk to them.
I know
Yeah.
Venkatesh. Yes.
Yeah.
Sure. Thank you.
Yeah. Yes. Yes. Yeah. No, there's no infringement. I said what has happened is they are not, LibreOffice and Microsoft Office are not fully interoperable because of the way standardization has happened, where in theory they are the same file format. They are, in theory, they are the same technical standards, but actually it is not, and that is deliberate. So what has happened is there are two different standards. One of them is Open Office XML transitional and Open Office XML standard. The transitional one goes into LibreOffice and the standard one goes to MS Office, which is why there are now interoperability problems. And now, like, I work with editors, and there's quite a bit of editing and writing process involved. And now I really can't use any document that's used via MS Office unless it's like really simple, just lines of text or something. So now, if I had to work, if I were forced, somehow to acquiesce to someone using MS Office, I would have to get MS Office. As a result of this, I can say, okay, MS Office not working for me, please use an alternative. I have the power to say that, but if I did not, then what would essentially have happened was that I would need to buy a license of MS Office because everybody around me is using MS Office, and LibreOffice, which I use, is not compatible. It's not interoperable with in all times, in all instances, not like fully incompatible, but certain instances, certain uses, it's not. Yeah. He can. So like I said, software is already protected by copyright law. It's already protected by trade secret. So yeah.
What happens is that, you know, it kind of then they can come to us and say, hey, you have to pay royalties for our using our intellectual property. But the argument that we put forth as the FOSS community puts forth as a counter is that, you know, basically programming is an applied form of mathematics and logic. You know, you do not patent mathematics and logic because, you know, unfettered use of that is essential to the progress of humanity. So I think this is a case where the lawyers have come in and, you know, twisted and ruined the entire field for programmers. And because the programmers are not very well aware of the issues, the lawyers have really prevailed. And we are trying to get more developers interested in this issue. So we have this website called endsoftwarepatents.in, and I request all of you, all developers, to look it up. Anybody interested in FOSS to look it up, because if we do not push back against this, I think programming is going to become very difficult. You know, just imagine if you want to build a e-commerce software, there are some 11,000 patents in the US on e-commerce. There are some 6,000 patents on online shopping. There are some, you know, thousands of patents on online payments. And as a developer, just to do that, just to build an e-commerce site, if you have to go through 20,000 patents, it's impossible. You know. So check out endsoftwarepatents.in, and you know, if you want to contribute to that, do let us know.
Okay. Yeah. Yes.
Hello.
Yeah.
I am Maxigas from the Critical Infrastructure Lab, and thank you for the presentation and for your work. My question is basically about the differences between the US patent situation and how patents work in India. So if you could speak to if there is anything specific to know about how patents function within the Indian jurisdiction. And for instance, I am mostly interested in patents about telecommunication standards in mobile phone communication. So if you could mention, for instance, is it customary for companies like Ericsson to also register their patents in India and other jurisdictions? Thank you.
Yes. So the way patents work, so copyright, for example, is, you know, it exists by default. You have to opt out if you want to give up your copyright. Patents are an opt-in kind of intellectual property, which means that if you want to assert that as your intellectual property right, then you have to register it. You have to register a patent application. And that is specific to jurisdiction, which means that for every jurisdiction in which you want a patent, you have to put in an application. So the big ticket patent litigation that happened in India, which started back in 2011, the paper I spoke about, that was by Ericsson and another company, Ringo, against Indian mobile phone manufacturers. And of course, to assert that patent, to be able to file that lawsuit in India, you have to have a patent registered in India. So all of, for it to be enforceable, you have to have it in India.
And do you think that patents can be a problem for developing the indigenous implementation of 5G protocols?
I might have to interject. We can continue the Q&A outside. We have our next talk lined up. Thank you, Rohini. That was an awesome talk that continued into an equally wonderful discussion. I would now like to welcome our next speaker, Ashutosh Pandey. He's a compiler engineer at AMD and one of the co-organizers at LLVM Social Bangalore, a large gathering of compiler enthusiasts, which is now over 1,900 members strong. What started as a local user group has now turned into a global community which connects academics, industry experts, students, and enthusiasts in compiler engineering. Please give him a warm welcome and have a happy talk.
Can I have this?
Yeah.
Hi. So a small quick show of hands. How many of you are involved in some or the other community on a regular basis, community or meetup? How many of you have heard of the LLVM compiler infrastructure? Okay, that's quite a few. That's nice. So I'm going to be giving this talk about scaling this community to 1,900 members and beyond, what we did, and my take on how we should scale communities. But since I'm here at IndiaFOSS telling people how to run a community, I have to establish a little bit of credibility. So I do tech. I'm a compiler engineer at AMD. I work on compilers. Previously, before graduating in 2021, I did Google Summer of Code with Arduino. I worked with the Linux Foundation on a glibc project. I interned at the Free Software Foundation and at Element 14. On the community side, I've been co-organizing LLVM Social Bangalore since 2022. LLVM Bangalore itself has existed for longer than that. And I've been a part of some other community initiatives as a student. So that's it. So what even is LLVM, right? So if you've never heard of this thing, so LLVM is a modular open source compiler infrastructure that can take a front end for any language and support a back end for any instruction set architecture. So in simple words, let's say you want your C code to run on on an Intel computer or on a Mac or a Raspberry Pi. So ordinarily, you would have to write 3 whole different compilers to do this. And for every set of languages you had to support, you'd have to go like N cross N for all the back-end infrastructures. So LLVM has a common middle-end optimizer. So all you need to do is target LLVM. You write the front end of your language. And instead of the compiler emitting assembly as it normally would, it emits LLVM. And then LLVM takes over from there. So it supports C, C++, Go, Rust. It's one of the most common compiler infrastructures in the world today. If I had to put it in simple terms, LLVM is more like, if a web equivalent were to be taken, it's like the entire MERN stack rather than just being one thing. You can use LLVM to create debuggers, linters, code formatters, and a lot of other things. So what do compiler engineers even do? We work on optimizations, squeezing out that last bit of performance from computers. We implement new features. So whenever programming languages come out with new standards, the standards committee is not the people who are actually implementing the feature. That's us. Then there's verification. I mean, I'm sure all of you write code, but whenever your code breaks, your first instinct is not to blame the compiler. you rather blame your code that my code must be wrong. So that means compilers have to be right most of the time, right? They can't be wrong very often. So verification and validation is a huge part of compiler engineering. And finally, there's the exciting bit that is research. So new tools like recently Meta came out with a tool called Bolt, LLVM Bolt. So it can optimize binaries. So you don't even need to give it source code. You can give it a binary and it can tell you how to make that binary go faster. So new tools, techniques, processes. So it's a sort of a unique field where, you know, academia and industry work together. So for the outsiders, you know, this is some of the tech powered by the LLVM project. Everything from the Swift programming language to the Android NDK, Julia, Unity, Photoshop, Polymage, TensorFlow, PyTorch, JAX, Postgres. All of them use LLVM in some form or the other. So what is LLVM Social Bangalore then? It is a community. It's a compiler-based community. It was started by two engineers, Aditya Kumar and Rishabh Sharma in 2019. So Aditya left for the US. He's in Google there. And Rishabh is pursuing a PhD. So now we've taken over. So the goal of this community is to build a strong compiler community in India. We organize meetups every month, although that's not all we do, but that's the main thing. We welcome professionals, academicians, and students alike. So in our group, you'll find professors, you'll find engineers, you'll find hobbyists, hackers, students, all sorts of people. So currently, it's run by 4 of us, Pradeep, Prerna, myself, and also with Aditya chipping in from time to time. So really, I speak for all of them here. So for an example of the kind of talks we have, here are some of them. So it's like we had a talk on enabling optimizations in JIT compilers recently by Dr. Manas Thakur from IIT Bombay. We had a talk on hot path SSA form in LLVM from Sumit Lahiri, who is a PhD student at IIT Kanpur. We had a talk on Build It, which is used to create domain-specific languages. So an example of a domain-specific language is SQL. So Ajay has created a tool that can build DSLs. He's a PhD student at MIT. And finally, Professor Santosh Nagarkate was visiting Bangalore recently during his sabbatical, and he is a professor at Rutgers. So he spoke about correctly rounded math libraries in the age of AI. So these are some of the talks. This is a picture from one of our talks. This was when Professor Sriram Krishnamurthy visited. So last year we also had a series. So this series is online. It's on our YouTube channel. So we had a 10-part series for outsiders. So typically we only focused on like experts in compilers and people already working in compilers, but this was the first time in like 4 years that we opened up and tried to cater to the general audience. So we spoke about compiler engineer careers, what technologies are used in LLVM, tools like CReduce, Clang tidy, Clang format, about code coverage, using LLDB and GDB, finding bugs with sanitizers and compiler flags. So it was a very interesting experience, and we introduced almost 800 people to compiler technology and systems through this series of talks. And this year we're organizing India's first compiler workshop. So just like the US LLVM meeting or GNU Cauldron or the other like compiler specific meetings like CGO, India didn't have a compiler workshop, even though we have world-class compiler engineers, if I may say so myself. So on this 20th and 29th September, we're organizing a compiler workshop. You can check out compilertech.org if you're interested in that. So that's mainly the first part of my talk, which was about LLVM. But now let's go into what lessons we learned from scaling LLVM Bangalore. And this is obviously my take on this, and you know what I learned. But if you disagree, then we can talk about it. So first is, first tip is identify your audience. So what I'd say is if you're starting out a niche community or you're in a community, identify who you want the community to be for. A community that is for everybody is not really a community for anybody. What I mean by this is, a lot of communities say that we're open to everyone, beginners, professionals, advanced people alike. In LLVM Bangalore, we knew right from the outset that we want to talk to existing compiler practitioners. We don't make an effort to antagonize beginners as such. Anybody can attend the talks, but most of the talks are fairly advanced and high level. On the other hand, if I was starting a community aimed at beginners, then I'd have a lot more entry-level talks. I'd have talks on, how to use Linux, how to use compilers, how to use compiler flags. The problem occurs when people don't know what it entails, signing up. Like, if you are if you're starting a community for beginners, then beginners are going to ask a lot of questions. You can't give them a README or some FAQ and tell them that go read this. If they were good at following FAQs, then they wouldn't be beginners. So if you're starting a community aimed at beginners, you're going to have to repeat yourself a lot. Your talks will not keep increasing in difficulty level as your community advances, and that's fine if that's what you want. But you should know your audience. Who are you catering to? Are they students? Are they professionals? Do they already have some background? And plan accordingly. Then the second point is sustainable consistency. So this is one of the things that I've seen that kills communities really fast, is that they try to do too many things too fast. 1 week the community starts, and then you have talks, you have lecture, you have meetups, you have workshops, you have paper reading sessions, you have 4 or 5 different things going on together. In LLVM Bangalore, we try to, every time we have a meetup, we do just one talk. Because I feel that after 45 minutes or 50 minutes, people start zoning out. And the main aspect is the community aspect. 1 week from now, you probably won't remember the title of this talk, or you won't remember me. But you'll definitely remember the people you met here. So we try to keep our talks limited. Like, if we have a meetup, we have either one long talk, which is like 45 minutes to an hour, or if we have 20, 30-minute talks, we have a couple of them. So, if you cram in too many talks and too many things, then people either just get bored, or the community bonding aspect of the community, you need to have time before the meetup and after the meetup for people to hang out. If the meetup itself takes 5 hours, then there's not going to be any time to do that. So don't do too many things. And we organize meetups at a monthly cadence because this is what we're comfortable with. Obviously, when we did our compiler workshop series, we did it on a weekly basis, and by the end of 2.5 months, we were really tired making slides, planning talks. So we go on a monthly cadence because that's what we're comfortable with. And variety is the spice of life. So you should occasionally mix things up. You don't have to have a meetup, a formal meetup where talks are presented. You can just meet each other for lunch instead. You can go hang out. You can do a paper reading session where one person just shares like an interesting paper that they've read. You can do a workshop where people code along with you. Or you can do an invited talk. You can do whatever you want. But keep mixing it up from time to time. That keeps things interesting. And one tip is don't take yourself too seriously. I've seen communities that have a president, a secretary, a treasurer, and you can call yourself the Lord Galactic Emperor or whatever you want, but it doesn't really mean anything. You're just an organizer. Don't let it get to your head. Don't worry about over-policing your channels that, if somebody is discussing something unrelated to your topic, conversations naturally drift into unrelated things. So don't over-police the community. Don't set too many rules. Don't worry about that. Just chill, relax. Titles and hierarchy are useless. Like, we feel this strongly because in LLVM Bangalore and even the community that I started in my college, Point Blank, we have only co-organizers. So there's no president or secretary. If you have to take out the trash after the meetup, everyone has to do that. If you need to make a poster, anyone should be able to do that. If you have to do marketing, anyone should be able to do that. You should have generalists in your organizing team that can do anything, right? So don't take yourself too seriously. And continuous feedback from the community. So this seems like a very obvious point, but the thing is, the community generally doesn't tell you immediately when things are going wrong. They're often really quiet. So you have to actively ask. So, there are some really small things like, what time of the day are you most comfortable meeting in? In Bangalore, this is a really big problem, right? So we do meetups on Saturday afternoons, not in the morning, not in the evening, bang on in the middle of the afternoon because that's the easiest for people to travel to. If we do online meetups, we can sometimes do them on different times, but you have to ask. If you don't ask for feedback, you will not get it. Beware of who you team up with. In a FOSS context, this is really important because there are organizations like Google Developer Student Club or Microsoft Student Learn Ambassador or some other company. So you might want to promote some tech, but you might be forced to promote some other tech, especially if you are in a tie-up with them, if you're taking money from them. In the recent conference that we are organizing, we got a very generous offer for a sponsorship, but the speaker wanted to give a talk at the conference. That was fine, but the talk did not meet our program committee's standards. The professors and the reviewers said that this talk is not good. So we rejected the sponsorship. So, you might have to compromise with your morals or your ethics or your standards if you team up with the wrong set of people or accept money from the wrong set of people. So please be careful about that. Develop simple workflows for the unimportant stuff. So you might have seen, like I showed you 4 posters of the talks, right? We use the same template. We don't design a brand new poster. We don't have a very complicated website. It's just a meetup page. We don't poll the community for every small thing. So speed up the decision-making process. In general, what I'd say is if organizing community meetups takes like more than 5 hours a week, you're wasting too much time. You need to identify the bottlenecks in the process and become more efficient. Make it easy for people to leave when they want to. This is sort of contradictory, but a lot of meetups and all, they work on things like, let's work on learning this technology together, which is good, but the problem is sometimes, people show up for one meetup, then they don't show up for the next meetup, and when they come to the third meetup, they don't know what's happening. So even when we did the compiler lecture series, we made sure to keep the talks discrete, like disconnected from each other. It's kind of like Marvel movies where you can understand the movies without even watching all of them. So make it easy for people to drop in and out. Finally, handle the handoff properly if you're a student community. If you're passing it on to your juniors, then please stick around for a while, help out the juniors. And finally, my last point for today is that it takes time. We took 5 years to get to where we are. There were months where we had 10, 15 people. There were meetups where it was raining outside and we sat with with filled boxes of food because 100 people signed up and only 15 showed up. It takes time. So to conclude, that was my talk. That's the link to our meetup page. If you want to attend any of our upcoming talks, you can. They were also on YouTube, so you can see all our past talks. Finally, my personal account, I'm on LinkedIn, so you can search for Ashutosh Pandey, AMD, you'll find me. I'll be around here also. I'm in a red t-shirt, so it should be easy to find. And you can email me at ashutosh@gnu.org. Thank you. Any questions?
Any questions?
So basically, when building, So basically, when building a community, right, there comes a moment where things start falling apart, right? And then the people that you're working with or you trust on, they start to lose some form of trust, or maybe information is being gatekept. So how do you make sure that people who are basically making the decisions for the community, how do you make sure they don't lose the trust in you?
So in general, I'd say that if you are, as a leader, if you are ever unsure about making a decision, just ask the community. That's the most straightforward thing you can do. And if the community itself, what I feel is that it's a self-correcting mechanism. if the leaders take decisions that don't represent the community, people will just leave. So if your community is growing, if people are getting added, if they're enthusiastic about coming to meets and doing stuff, then you're on the right track. If people are getting disinterested, if things are dying off, then you're probably doing something wrong.
Okay, yeah, thanks.
Yeah. Anyone else?
Okay. Thank you, Ashutosh. That was an interesting talk. I'd agree with all your lessons taken. Up next, we have Shafiq and Sonu Kumar Singh, both key contributors to the open source Gardener project at SAP. Shafiq is a mechanical engineer who's turned into a software developer from IIT Guwahati. He is passionate about building scalable and secure systems. Sonu, with a strong background in cloud native technologies, is dedicated to enhancing Kubernetes cluster management. Today, they both will share insights on how they host homogeneous scalable Kubernetes control panels across multiple cloud providers using Gardener. So let's give them a warm welcome.
Good morning, everyone. So today, Sonu and I would be presenting our project Gardener. So we provide homogeneous Kubernetes clusters at scale across all major cloud providers and also data operations with minimal TCO. So how many of you folks have heard about Kubernetes? Oh, that's quite a lot. Okay, so for those who don't know, so Kubernetes is a container orchestrator. So it has become the de facto standard for the same for quite some time now. And it's used widely to run cloud native workloads. So let's just also just see a small overview. So Kubernetes basically uses reconciliations, which acts on these observe, analyze, act loops. So they observe the state of the system, and then they work towards achieving a desired state. Also, we have two planes. One is the control plane, which has all the control components. So for example, we have the kubeAPI server, which is the central entry point to the cluster. Then we have HCD, which is a highly available key value store, or it's the database for Kubernetes. Then we have some controllers which work together to achieve the desired state. Then we have the data plane where the actual workload runs from the user. So we have some components there, kubelet, kubeproxy, etc. So as a user, so if I want to get something, so who do I talk to? So I talk to Gru, or in this case, it's the kubeAPI server, which is running in the control plane. But when we ask something, so kubeAPI server does not work for itself to achieve it. So it will delegate the work to the minions. So in this case, the minions are the data plane. So yeah, so the user just declares the decide state, and then yeah, all the controllers work together to achieve it. So about managing Kubernetes. So it's easy to deploy an application in Kubernetes, but it's just the tip of the iceberg. So what goes on underneath it? a lot of things. So operating Kubernetes can be quite challenging. So once you start using it, you will quickly realize that it's just not about deploying containers. There are numerous other components to manage, like networking, observability, then there are resource allocation, auto scaling, and much more. So it might not be very straightforward as it might initially seem. So, and this complexity isn't very scalable. And especially when many teams within an organization want to run Kubernetes and they want to use different cloud providers, let's say AWS, GCP, Azure, etc. And they also want to run different OS, they want to use different networking plugins. So then it can be tough. So we need to know their intricate details, their command lines, we need to learn a lot of things. So also, let's say you want to deploy kubeAPI server, we have a lot of flags in it. It's not visible much, but yeah, we have a lot of flags that we need to be familiar with. Then let's say kube controller manager, similarly kube scheduler, and the list goes on and on. So and misconfiguring any of these can lead to issues which can affect the whole cluster, and it can be quite challenging to maintain a secure environment. So then how do we deal with this? So we have to go for a managed Kubernetes service. So then we were left with two choices. So either choose an existing managed Kubernetes service like EKS or GKE, or then and then we had to face the limitations which come with them, and we also had to pay them tons of money. Or we can build our own solution, and which will cater to all our needs, which is homogeneous across cloud providers, and we should be very scalable. It should be self-healing, meaning we don't need to micromanage it, and also it should be cheap. So guess which pill we chose? So we decided to build our own solution. And where did that take us? As of today, we are running with more than 7,500 clusters, which uses over 50,000 nodes or virtual machines, and uses over 700,000 CPUs and close to 5 petabytes of memory. But how exactly did we achieve this? The answer is kubeception. We use Kubernetes to manage Kubernetes. But how exactly does this work, you may ask? So as explained before, we have a control plane and a data plane. In this case, in Gardener, the control planes of different clusters, different child clusters, run as pods in the parent cluster, as seen here. So they are just workloads for the parent cluster, and the example, the kubeAPI server, etcd, all the controllers, everything run in the parent cluster. So in a normal case, a control plane would need separate VMs for each of the cluster, child cluster, but in our case, this parent cluster is shared between them. And let's also look at some terminologies. So in Gardener, we have this garden cluster, which is the resource meta cluster, which holds all the custom resource, which is managed by Gardener. Then we have the seed cluster, which is the parent cluster that I talked about. So all the control planes are hosted in the seed cluster. Then we have the shoot cluster, which is the cluster provision for the user. So all the nodes will be running in the user's infrastructure account, so they have to bring their own infrastructure secret. And also we use similar Kubernetes terminology. So in place of kubeAPI server, not in place, in addition to kubeAPI server, in Gardener we have Gardener API server, then Gardener controller manager for kube controller manager, scheduler. Then we have a component called Gardenlet. So in Kubernetes, a kubelet runs in the node and it manages the pods. So in Gardener, we have Gardenlet running in the seed, and it manages multiple shoots. So we can have seeds for different infrastructure and different regions, and then it can host the control planes of multiple shoots. And also Kubernetes have the CLI tool kubectl, and we have GardenCTL. But what is a shoot? So shoot is a Kubernetes custom resource which contains the configuration for all the things that the user might need, and they need to know to get the cluster they want. So be it provider related, OS, networking, and whatnot. So every configuration is present at one place, And this is the same across all the cloud providers. So, and also all OS, all networking plugins. So the shoot YAML does not change. So you need to learn only this, and you are ready to get a cluster with any supported infrastructure and any OS or any network plugin and so on. And let's also talk about extensibility. So Gardener is extensible by design. So this extension concept is an out-of-tree architecture that keeps the Gardener core logic independent of provider knowledge or networking plugins and OS, etc. So this is similar to what Kubernetes have achieved with out-of-tree cloud providers or with CSI volume plugins. So for example, during shoot creation, Gardener creates a infrastructure resource which will be reconciled by its respective controller, and similarly for network, OS, container runtime, etc. So if one needs to extend this, so they can write their own set of extensions to support a new cloud provider, and they don't need to touch the core code base. And this is also a way to contribute back to the community. And in Gardener, we also have more in-house components that are designed to work particularly with Gardener, but that can also, that is part of every hosted control plane, but that can also run independently outside Gardener. So we have Garden Linux, which is a Debian derivative, and it has a lot of customization features. And then we have etcd Druid, which is an operator used to configure, provision, reconcile, and monitor etcd clusters. Then we have the machine controller manager, which provides a uniform Kubernetes API to manage the lifecycle of machines across cloud providers. And we'll move on to the features of Gardener. So I'll hand over to Sonu.
Hey everybody. So I'll talk about some of the key feature of the Gardener, which Gardener provide. So starting with first one is the hibernation. The idea is at some point of time you don't need your cluster, for example on weekends, or if you're a developer you don't need your cluster during your off work hours. So you can simply send your cluster to hibernation. What basically means is when you hibernate a cluster, all the VMs will be deleted and a control plane will be shut down. So this will save a lot of money, because the main thing which costs the money for a cluster is virtual machines that will be deleted and shut down. Next feature is high availability. In general, in Kubernetes cluster, you will have only one replica for all the control plane components like etcds, QAPI server, and others. This can lead to downtime in certain scenarios. For example, if a node get deleted or a zone goes down. So if a node get deleted, the etcd running on that particular pod will get deleted, and it need to come back on some new node. So it will take some time, and this will cause a downtime. And for the zone case, there are certain cases in the past where whole cloud provider zone goes down. In that case, the workload running in that particular zone will face downtime until the zone is back. To deal with this issue, we offer high availability. So in place of one node, we run three replicas for etcd and QAPI server, and all other components will run in active passive mode. We offer two kind of HA configuration. One is node, the other one is zone. So in node HA configuration, what we'll have, like all the replicas will be span over multiple nodes. So if a node is getting rolled, you'll not face a downtime because the other replicas will be there to serve the request. In case of zone HA configuration, high availability configuration, what will happen, the pods or replicas will span over multiple nodes, and specifically those nodes will be spanning over multiple zones of a particular cloud provider. So what will happen, even if the zone goes down, other replica will be there present in other zones to serve the request. Next feature is control plane migration. So when the organization grows, there are certain use cases. There are certain scenarios where, because of the business use case, people like, or one would like to move their control plane from one location, one cloud provider region to another cloud provider region for providing better latency and other reasons. To serve this feature, we offer control plane migration. So one can migrate their control plane from one cloud provider region to another cloud provider region without the need of deleting and recreating the cluster. and without affecting the workload of the users. Next up is disaster recovery. Gartner supports backup and restore of HCD. We have a in-house component called HCD backup restore component, which backs up the data of HCD backing the shoot cluster regularly. And in case of disaster, where all the data is get lost for whatever reason, you can just recover the HCD using that backup. Next up is workerless cluster. So in this case, you'll see there are no minions, that is there are no worker nodes in your cluster. So there are certain scenarios, use cases where you don't, you need a cluster which does not have any node. You only need the features of control plane. So in Gartner, we can create so-called workerless shoots, which are exactly that kind of Kubernetes cluster, which does not have nodes and it only has control plane. Up next is credential rotation. This is one of the key feature which is offered by Gartner. And what I know so far, no other any major managed Kubernetes service provide this feature. So in a Kubernetes cluster, you'll have multiple secrets or multiple secrets. For example, kubeconfig, CAs, observability password, and some others. The thing is, for compliance reason, you have to regularly rotate them. And for security reasons, also you have to regularly rotate them. Doing this manually, one by one, or doing is very tedious and cumbersome task. In Gartner, you don't need any of those things because, and you can just simply rotate the credential, which is only the set of annotation. Apart from the feature mentioned, we have another set of a lot of features like auto scaling of cluster, where cluster size can increase or decrease based on the requirement or the workload. We offer maintenance window, so shoot can configure a maintenance window, and Gartner will apply some of the changes to your cluster during that maintenance time window. And also some of the things can be configured to update in the cluster, which will be happen only during the maintenance time window. We also offer automatic OS and Kubernetes version upgrade. So if configured in the shoot, during the maintenance time window, Gartner will automatically update your OS versions and Kubernetes patch versions. So we are back to demo time. We'll head over to the Gartner dashboard. So this is how Gartner dashboard looks like for Kubernetes clusters. So here is a list of the projects. In the Gartner, we separate Kubernetes cluster with projects. So in an organization, a person or a team can create a project, and all of their clusters will be residing in this particular project. So if you see, I have created a project called FOSS for this particular demo. And I already have two clusters running, cluster 1 and cluster 2. I'll go on and I'll show how easy it is to create a cluster using Gartner. You just click on the create button. As of now, everything is running locally, so you see only one infrastructure, which is local. In the actual scenario, you'll see multiple things like AWS, GCP, Azure, and others. For cluster name, so then up next is a cluster name. I will name it FOSS 2024. You can then after that you can select Kubernetes version from available list of Kubernetes version. 1.30, I will select the latest version. Then the purpose of the cluster, you are going to use it for development purpose, production, or whatsoever. So I'll select the evaluation. Then there is workerless cluster, the clusters without the nodes. I'll not check, as of now I'll create the cluster with nodes. Infrastructure details, it's one of the important things. So if you see there is a secret, it's a secret which is provided by the user, and all the infrastructure resources like VMs and other things will be created in this user account. Then you select the regions from the available set of regions on the cloud provider, networking type, Calico, Cilium, then HA configuration for like node and zone HA configuration, some other thing. And then in the workers. So in the worker are basically the nodes of your Kubernetes cluster. You can select the architecture type of your nodes, which is AMD, ARM64. Then machine types, it will be there available based on the machine present in that particular cloud provider. Machine image, the container runtime like containerd, Docker, Then this is autoscaler min and max. So min is the minimum number of nodes which need to be present at any point of time in the cluster, and max is the number of node which will your cluster can scale up. Then few of the add-on features are there like dashboard, Nginx ingress. Upcoming up is the maintenance window. It's a window in which Gardener performs certain update on the cluster. You can also select automatic update of the operating system in the Kubernetes version in your cluster. And if selected, during the maintenance time window, Gardener will automatically update these things in your cluster. Up next is hibernation. So you select the hibernation schedule according to your needs. So if you're a developer, ideally, I guess you would be checking out at 5 p.m. So you can just select your cluster will get hibernated every day after 5 p.m. And then you go in and hit the create button. Yep, and your cluster is ready. So I'll summarize it with this slide. With Gardener, creating Kubernetes cluster is as simple as this. You don't need any special equipment or gear to use Kubernetes. Just few set of clicks, and we'll give you a production-ready Kubernetes cluster. Coming back to the slides again, I will show you the cluster which we have created. Everything will, at the end of the day, will translate to a YAMLs, and you can see there are things like Kubernetes configuration, your hibernation schedule, the nodes configuration, like CRI and whatnot. Everything will come down to this stuff. Also, in the dashboard, there are tiles for cluster, which shows the readiness and health of the cluster, like this API, control plane, nodes. So it shows like if your QAPI server is ready or not. Your control plane components are ready or not. Your nodes are ready or not. All of this can be checked through this. Also, we have our in-house tool called Garden Cuttle, which can be used to target the cluster and their control plane. I will go on and target one of the cluster, which I have already created the cluster one. You can just check this thing, and yeah. Type this, and yeah, we have targeted the cube. As of now, the cluster one. I will go and list the namespaces in this cluster. And if you check, this is the plain vanilla Kubernetes cluster. When you use Gardener, you get a plain vanilla Kubernetes cluster. There are certain set of pods which we create in the kube system namespace. Yeah. So Gardener creates certain set of pods in the kube system namespace to support the Kubernetes cluster. And similar to targeting the cluster, you can also target the control plane of this Kubernetes cluster using same Garden Cuttle tool. And when we target, we are targeted the control plane of the cluster. This is a whole set of different Kubernetes cluster, and everything of the cluster which you're seeing will all the control plane components will be running in some other Kubernetes cluster as a native Kubernetes workload. So I will go on and list the pods. Yeah, and there are all the pods which you see in general for a Kubernetes control plane, like etcd is there, QAPI server is there, kube controller manager, and kube scheduler, and other stuff. I'll come back to the slides again. So, yeah. So in summary, what is Gardener? So Gardener is homogeneous. It provides identical day one and day two operation across cloud provider. It's open source grown. Gardener is developed in public, pioneered by SAP. And all the projects under Gardener comes under Apache license. It's ultra scalable. As you have seen, we have already scaled the number of cluster in SAP to 7,000 and more. You can use Gardener to scale your Kubernetes clusters with manage thousands of clusters with minimal TCO. We are 100% compliant, Kubernetes compliant. It provides same experience across cloud provider, be it AWS, GCP, Azure, or Ali Cloud, and others. It provides self-healing capability. So with time, it provides self-healing capability. So everything in the Gardener runs as a native Kubernetes workload. So if anything goes down, it will come back on itself. Sorry. So this is how cloud native ecosystem look like. There are multiple things like container runtime, registries, databases, and all. And Gartner stands right here, which you see. It's a platform which provides 100% certified Kubernetes installation. So who else is using Gartner? Apart from SAP, there are multiple adopters of Gartner. Yeah, like StackIt, Metal Stack Cloud, and some others. So to learn more about Gartner, you can join our community. You can join our Slack group and follow us on GitHub and other platform. And thank you. You can scan this code to learn more about Gartner. And we are now open for questions.
Does anyone have any questions? We would be able to take only one question because of the time, but we can have him. You can go ahead. Everyone else, you can ask them outside.
Yeah, sure.
So I have a question related to the auto scaling. Then when you were creating the cluster, so you're providing the auto scaling parameters, right? Is there a way we can also include based on custom metrics like TPS or based on CPU when it throttle, then the pods get auto scale. Is there a way in the
You're asking about pod get auto scaled or number of nodes. So what you see that auto scaling is about the number of nodes. So you set a minimum number of minimum nodes. So when the workloads are less, overall request is less, it will have the number of nodes, and accordingly, and the max number of node is the number of nodes. So when the workload increases in the cluster can scale up to that certain number of nodes only. So it's needed for the cost. Otherwise, you can scale your Kubernetes to infinity and number of nodes. So that's why there is a minimum and maximum. So at what is the maximum of nodes which you want at any point of time in a cluster?
Yeah, but there is a way to customize, like custom way of scaling based on the Prometheus query. Based on the Prometheus query, you can provide the custom query.
So we use cluster autoscaler, which is used to scale the number of nodes based on the request.
Okay, sure.
Any?
Okay, I think we can have other questions after outside.
Sure. Thank you.
A quick announcement before we proceed to the next talk. So post lunch, we'll have some lightning talks happening in Audi 2. If you have any topic that you'd like to talk, you can write it on the
FS to EPBF and all the implications that can have on security, which is why I think you would believe me when I say that I was surprised when I asked him what he'll be talking about, and he said he'll be talking about bees and F1 racing. So please give a round of welcome to Barun Acharya for his talk.
Hello, everyone. Last session before the lunch. Hopefully, you are not all tired. One more session after this? Okay, so not the last one. You will need to bear with me and one more. So, yeah, my session will be on beekeeping Linux, evolution of kernel technologies, like where did in general instrumentation start in Linux or Unix, and how did it evolve to why I'm calling it bee, all the mystery behind why I'm calling it beekeeping. We'll explore all of that. I'm Barun Acharya. I go by the username demon1024 over the internet. Akshay already told me about myself. I work as a software engineer at Equinox, working on open source projects. I'm currently a maintainer of CubeArmor. I have this cool t-shirt. More details about how to get this t-shirt at the end of the talk. And yeah. So instrumentation. How many of you know about instrumentation or are instrumenting your operating systems on production environment? Any raise of hands? Some of you, okay, nice. So before I go deeper into what's instrumentation, I'll take an example of F1 racing. So, any fans of F1? Oh, nice. Any fans of McLaren? Good enough, good enough. So, F1 is a very interesting concept, right? You have a driver driving like those fast cars on their circuits, but lot of things go behind the scenes as well. You have rains, you have weather. Maybe the weather is now 40 degrees, your tires heat up much more. Now, so you need to take more pit stops and accordingly change tires. And all these takes data. You need to instrument inside your tires that, okay, there's a temperature monitor in tires, there's a pressure monitor in tires, or there's a temperature monitor in engine that, okay, your engine is not overheating. And what is the fuel level, like what's the rate at which the fuel is getting consumed so that they can appropriately time the pit stop. As you all are fans of F1, so you might know that, okay, how just a half-second pit stop delay can result in a loss in a race. So all those details are very important, and they do a lot of things. So this was the McLaren booth at KubeCon Paris, and that's me trying to pretend to be an F1 driver. But just to give some context, they have all these dashboards running live in their environment. Splunk is associated with McLaren, Mercedes, Oracle, all have their own infrastructure and monitoring dashboards. They have these cool dashboards to realize, okay, where they are. They have their full race view. But what goes behind this, we'll talk deeper now. So that was why we need to instrument in general. Like we are instrumenting the F1 cars right now, but similarly, we need to instrument our kernels as well. You never know on your production environment, maybe the server heats up and now your CPU is getting throttled down. Or suddenly there's a spike of 10,000 users that you did not expect. There's a Black Friday sale you predicted for a 1 lakh user, but now there's 2 lakh users trying to buy something. So those are the reasons that you need to instrument something. And in general, your production systems have a lot of moving parts. So accordingly, instrumenting and trying to understand individual parts, which should I monitoring, what to not monitor. I don't want too much data. I don't want to get confused around and fall off this. Imagine getting hurt falling off this. So that's the reason we need to understand instrumentation in a much deeper and correct way. So we'll take a look at history, like how in general Linux, so like there are a lot of software out there which help you instrument things, but what goes under the hood, that's what we will be focusing on today. I'll start with the first one, that's devmem. So as all of you know, everything is a file on Linux, right? So there is a file in Linux which can help you access any data on your memory. So that's devmem. You directly get to see all these hex dumps and try to access them. And kudos to you if you can figure anything out of that. But there are tools out there which can operate on top of this and you can figure things out. But the issue is, because you get so much raw data, accordingly, it's very risky to access them as well. Any incorrect access can result in your, like, imagine the F1 car, it may just explode there. So you don't want that happening, right? So in general, in Linux, this is not allowed right now because this is behind a configuration called config strict devmem. So the access itself is restricted. But if you are courageous enough, maybe try enabling it and playing around with it. We'll go to some safer ways. Let's say ptrace. So ptrace has been in Unix from 1975. It was introduced by Bell Labs. And it has been in Linux from its inception. What you can do is you get detailed real-time view of, you can intercept actual system calls to understand what is being done by a specific process. And accordingly, you can try to inspect and manipulate the running program. Any of you here use debuggers? GDB, Delve, yep. So behind that, ptrace is in action. They use ptrace to actually intercept so that you add those breakpoints and you can intercept what's happening inside individual lines or function calls. That's what ptrace is about. It's essential for debugging and pinpointing problems, but because it is so intrusive in nature, imagine adding a breakpoint and stopping the entire thread. That you doing in a production environment is not something you would want to do. And that's why it's non-performant in nature, and you cannot do it, run it in production environments. An example here was that this is a sample application built by Rudraksh. He's in the, and you try to cat the file, and the exact exec v call is trapped. You can choose to stop the thread there, and it can close, and you can choose to deny it or just modify what is being written to file. All those controls are available as part of ptrace. Next is, because ptrace was so intrusive in nature, we discuss about procfs. So anyone has played around procfs here? A lot of you. So procfs has been there in Linux from Linux 1.0. We are on Linux 6.10 right now, 6.11. So it has been there from the start, but it was there from 0.8 or something, but actual production Linux, like general availability, was from 1.0. You can extract details like CPU usage, memory usage, device statuses, what was the actual process that was executed. So an example of that is, I just listed down what all processes are running on my system right now. So I did that. I got access to Firefox, GGS console, LS. So this was the LS that was executed, and you can see it has a keyword called self. So it can trace actually itself as well. So as it gets executed, it gets populated in that file system. A more valid use case of this is CPU usage. Top users. So everyone does that, right? Your CPU is starting to slow down. You just run top and see which is the top memory user or CPU user. Under the hood, this is the bash command that it might, like, it's much more optimized that way, but you can actually trace procfs to try now. So this was the Firefox binary that I did. So you can see isolated web container. This is the raw data, but neither I can understand, if I don't think anyone of you can understand. So I passed it to something, and I get the CPU usage to 2.6%, and every second it will keep tracking. But now the issue here is that I need to poll this information. So because this information itself is reflected in the user space, the data is like, there's a latency in when I observe this data. And this is not real time. You are actually catting, like extracting this from a file. So there's always a latency involved. So all of what we discussed right now was trying to trace this information in the user space itself. But we were talking about kernel instrumentation. So we can hook into the kernel itself as well. So this is a diagram from Julia Evans' blog. So there's probes and there's trace points. These are hook points inside the kernel, which you can hook into and extract information out from. Exactly like what I did from procfs or ptrace, you can do all of those from here. But because they are inside the kernel, you get them in much more real time, and you can instrument them in a correct way. But because they are inside the kernel, how do I hook into it? I cannot just go ahead and start modifying kernel code and trying to access it, right? So that's where the front end comes in the picture. So there have been a lot of tools historically to actually leverage these k-probes and trace points. We had system tap developed by Solaris, I guess, and don't quote me on that. There was dtrace, there was ftrace, there was perf. You can instrument all of these to hook onto those k-probes. So like I can monitor actual CPU resources or process execution. We'll see a demo right now. And finally, eBPF was introduced, and that's what we'll be talking about. So the bee keeping comes from eBPF because the mascot for eBPF is a bee. So that's the mystery behind the bee. So what's eBPF? eBPF is extended Berkeley packet filter. But what it essentially is, it provides a safe, programmable, and performant way to intercept our kernel. So You have your applications running, you have your library files, they make some system calls, and there's your kernel. That's where eBPF resides in. You can load your actual code into this, and you can instrument it in a correct way. So you can send this data to user space and accordingly drive from there and utilize it for your own. This is taken from a popular eBPF project, and it's called IO latency. So imagine trying to, everything is a file in Linux, right? Imagine trying to intercept each of them and calculating what was the latency in actually trying to communicate with the IO. So that's what this is about. This is sampled for every second, but between 0 to 1 ms, there was 1913, 438. So all these counts exist. So you know that it is being done in real time, even though the output is at a later stage, but you can consume events in real time and accordingly further like create the pipeline to trigger what you want. We'll look at some actual examples as we follow. So what I was trying to deliver was that because there were some certain issues with procfs, ptrace, dtrace, ftrace, all those tracing mechanisms, we talked about eBPF. I glorified eBPF in a certain way that you may think that, okay, maybe this is a silver bullet. Maybe I should use eBPF and all of my observability problems will be solved. But is that true? For that to understand, we need to understand what's the difference between tracing and sampling. So tracing is what we were checking right now. We wanted to trace individual IO happening. Each time an IO event is there, I want to trace the latency of it. So that was tracing. And sampling is, I take a larger data set and I sample it down that, okay, my CPU usage was 50%, 52%, 55%. So the sample data would be 53% maybe. It's averaged down and I get a sample data. But in which form, which is more relevant to me, that's something we will take some practical examples around. So let's start with a security example. I want to understand, I want to know as soon as a root access is made. So I've defined my user groups in Linux, and any root access is made, I want to trace it. So that's where tracing comes into play, because I would want to get alerted, I want to take action. In general, I have configured my Linux system in a way that no root user access should not be made. So that's, in that case, I wanted to alert me in real time that, okay, a root access was made and maybe denied. There are tools out there which can help you deny it as well. But what if I just want to do it from a compliance perspective, that there's all, like I know that my applications make root access, but I want to create an understanding of which all applications do these root accesses. In that case, it's an example from OS query. It's a popular project that, okay, I did a select star with where username was root and I got the timestamp and which PID was it. So in this case, maybe a sample data is enough for me because I don't need to worry about it getting in real time. I know that root accesses will be made. I just need an exhaustive list of data that if the root access, like what I can do to alleviate it in future. Taking the next example, so file integrity monitoring. Quick question that, so like file integrity monitoring is that I have certain file set, I know they are sensitive to me, it should never be modified. What do you think, whether we should use tracing or sampling here? Hands raising for sampling, hands raised for tracing. So that makes sense. All of you already understand it, so I'll not go deeper into it. But yeah, because I want to get alerted in real time that any file is monitored, I would want to go to the tracing approach. And similarly for memory map processes, as soon as, so in general, you would execute bash or something like that. In that case, you see the actual file name of whatever is being executed. But in case of memory map processes, you don't get to know what was executed because there's no file written on your disk. So this was a sample, this is a sample command to extract the list of memory map processes from procfs. But depending on, again, my use case, whether I want to just understand how many memory map use cases were done, or I want to get alerted in real time that, okay, no memory map processes should have been executed, I would go with the tracing or sampling approach. Observing resource usage to reduce cost. So I have maybe tens of thousands of machines running on my like data center, and I just want to see how many of them are underutilized. In that case, tracing would be too much, right? I implementing tracing on 10,000 of my virtual machines to understand what's my CPU usage in real time on every microsecond. That would be too much. So that's where sampling approach comes into play, that, okay, every 1 second or 2 second interval, I take the CPU usage and accordingly publish it to a pipeline, and I can debug from there that, okay, maybe machine number 100 is underutilized, so I'll scale it down or something like that. Detecting memory leaks. So how many of you had to debug a memory leak problem in your environments? Or are still debugging? So maybe this is a daily job. So in case you're dealing with memory leaks, you may be attached to a pprof or something like that. But what do you think? Are we tracing real-time memory there, or are you okay with the sample data there? Tracing? Okay, there are hands for tracing. Okay. And like sampling, I'm assuming rest of you are sampling. Yeah. So, and this is a subjective question, because if the memory leak is in a certain time, that if the memory leak happens in this interval, that, okay, there was a spike, then it reduced, and it goes in that stopgap pattern. In that case, maybe you would need to do tracing, because in that 5-second interval, your memory is again reset by maybe garbage collector or something. But in case it keeps growing, sample data is fine, because even after 10 seconds, my memory will keep increasing. So at 1 minute interval, I would know that, okay, my certain component was using 1 GB of data, now it's using 2 GB of data. So that's where it increases, and that's how it's handled. So yeah, that was about tracing versus sampling, and in general, instrumenting your Linux kernel. Thank you.
Some of you may have questions about the talk. Maybe PF. You can. We can have one question if we have them. Any questions?
Cool. So we have a booth. I'm at the CubeArmor booth. It's on the first floor. We'll have a quiz and swag distribution at 3:30 p.m. Do join us there. And this is CubeArmor GitHub. This is my personal blog. So if you want to check and get more details about me, feel free to connect. Thank you.
Thank you, Demon1024. That was an interesting talk. Our next speaker is Abhishek Datta, the creator and maintainer of WET, an open source tool designed to help product security engineers vet open source software components. With deep expertise in open source software supply chain security, he focuses on identifying threats and building tools to mitigate them. Today, he'll guide us through the critical topic of safely and securely consuming open source software, highlighting risks and best practices, and introducing us to his powerful tool WET. So let's welcome Abhishek to the stage.
Hello? It's not connected. It's fine. Hello? Hello? Hey everyone. Sorry for the technical glitch. And it's the last session before lunch. So, there is one more session, is it? Okay. So, but I'll try to make this interesting. It's a slightly different topic. Everyone here is using open source. Let's look at some of the interesting security aspect of open source. My name is Abhishek Datta. I'm the creator and maintainer of VET, a free and open source tool, security tool that I'm going to talk about today. I had been a security researcher in a past life, but lately more on the platform engineering side of things and more on the security defense side of things. Let me start with a question. Who uses FOSS? So everyone, right? So this is IndiaFOSS. I'm assuming that everyone is somehow associated with FOSS. Either you are already contributing to FOSS, using FOSS, or aware of FOSS, right? To give an analytical answer, I would quote Linux Foundation, which says, any modern software solution built today consists of 70 to 90% of FOSS in the final software that I'm shipping. Say, even if I build application using, say, Spring Boot or something, and I like write some, a million lines of code. Even then, the final artifact that I'm shipping would heavily contain free and code from free and open source software ecosystem in terms of libraries that I depend on, libraries that I add, and their transitive dependencies. If you're familiar with SBOM, or if you really look into the software composition, you will see that every software built today has very, very high dependency on FOSS. Is there a cost to FOSS? It's free, right? Do you think there is a cost? I would say that if you are building software professionally, there is at least a security cost associated with FOSS. There is a cost of vulnerability, there is a cost of potential malware, and there is a cost of maintenance. The reason for that is this. You may be say a great software engineer, your code to bug count may be very low. But if you are responsible for running a professional software engineering team, then you would most probably not depend on personal brilliance. You would most probably architect a SDLC that maximizes the chance of your team shipping software which is secure and high quality, and minimize the chance of making mistake. Eventually you would do that. You would ensure that your team ships secure software. How can you guarantee the same for the open source libraries that you are consuming? If you choose open source dependencies that are at least as secure and as high quality as your internal code, you will end up maintaining the security and quality of the final software artifact that you are shipping. But if you choose open source libraries or open source components that are insecure or poor quality, even if you practice high quality SDLC within your organization, it will lead to you shipping software artifacts to your customers or deploying it in your infrastructure that has security issues or other challenges. For example, these risks are real. I'll give you an example of one of the commercial software pretty popular in the enterprise among enterprises, where there was an unauthenticated remote code execution vulnerability because of a vulnerable third-party dependency in the authentication system. The fix was simple. All they had to do was upgrade to a fixed version of the library, right? But when you are using open source software, you have to deal with this. That's why there is a cost to it. There is a cost for you to maintain. There is also the case of, malicious dependencies or malicious code getting shipped in newer version of dependency. For example, one of the popular libraries called ConnectKit used in the the crypto wallet and crypto application, decentralized application ecosystem, was compromised and malicious code was shipped in a newer version. So by the time the security team of the company maintaining that library figured out, there was loss of approximately $600,000. So, and I'm sure how many of you are familiar with the XZ incident that happened some time back? Do you think it is scary? I think in general we got lucky because someone who cares madly about performance saw a few microsecond delay and took the time to investigate, and something massive came out, right? If you are not familiar with it, I suggest definitely go and read at least what happened or what could have happened. So if you care about shipping software that is secure and high quality, it's not that you can replace FOSS. FOSS is too valuable. It is irreplaceable, right? We all depend on FOSS. My security tool extensively depends on other free and open source code, right? We cannot replace them. But what we can do, we can adopt practices that will allow us to choose open source code, open source libraries and other components that meets our security and quality standard. That is the goal of building this project called VET, that really allows you to vet open source library for use. I'll talk about it. You'll probably see that it's very easy to use and integrate as part of your SDLC. So what is VET? VET is currently a CLI tool written in Go, built with the goal of implementing policy-driven vetting of open source libraries. I'll talk about the policy and how it helps. At a high level, VET's architecture kind of looks like this. Unlike most other security tools, VET does not have an opinion of what is risky, what is not risky. VET has components that resolves that scans your application code base and package manifests like say pom.xml or packagelog.json, and identifies all the third-party dependencies that your application depends on. Then it uses data from public ecosystems, security metadata, to enrich those identified dependencies, and it just applies the policies. So if I have to say what is VET, what's so special about VET, nothing much. It's primarily a policy engine. It allows you to codify your opinion of safe and trusted open source components. If you decide that in your organization you don't want to adopt libraries which has a critical vulnerability, or you don't want to adopt libraries which is not maintained in say 2 years, or whatever criteria. Maybe I think OpenSSF has a booth here. They run a project called Scorecards. You want to decide that for any library that you use, these are the open scorecard criteria that we met. You can define them as policies in VET. Policies are very simple. I'll talk about it. And VET will ensure that any change in your third-party open source dependencies identified will be vetted against the policy that you define. VET policies are VET uses CEL, Common Expressions Language, as its policy engine. The reason for this choice is really expressions, because we have seen over time that policies may become very complex. So we wanted to ensure that our policy engine or policy language only has expressions and no statements or anything. And in general, we believe that CEL helps keeps things very simple. So whatever your opinion of open source is, you can codify as CEL expressions, and VET will automatically leverage that. For example, in this case, this is an example of a simple policy that identifies any packages with one or more critical vulnerabilities, right? I will not really give a demo of VET because I want to talk about some of the very interesting problems that we are solving and which you will most probably find very relevant. I would like to believe that VET has decent documentation, but happy to be surprised. So you can get started with VET using its GitHub project or using the documentation which is published. We also have some videos on getting started. VET also have a native CI/CD integration with GitHub Action. So if you're using GitHub Action as your CI/CD, you can get started with VET in 5 minutes. You can just add the VET action, which is a GitHub action, and it will integrate with your pull requests, GitHub's action pull requests, and it will vet any changes which is detected as part of the pull request, like any new library added or any new library updated, and it will vet those changes against your defined policies. This is how it will look like. It will add a comment as part of the pull request. Just like VET, most security tools are good at identifying problems. How many of you work in an organization where there is a separate security team who finds problems? How easy do you find it to fix those problems? Easy, easy, very easy, difficult, little difficult, or very difficult, right? The problem with security tooling is that it is generally easy to identify and hard to fix. Especially with the class of tool. VET can be kind of categorized into software composition analysis or next-gen software composition analysis tool. Similar to, say, Dependabot or dependency review. If you use GitHub Advanced Security, then you might be using GitHub Dependency Review. These tools can find vulnerabilities very easily. Just like VET, what VET does, or VET or this kind of class of tools does, is they enumerate all the library versions that your application depends on, then queries a public database like, say, CVE or OSV to find all the vulnerabilities that impacts a particular library version, and then just gives you that list of vulnerabilities, right? So if you are using, again, I'll give Java example, Spring Boot version X, VET-like tools, free or commercial, will query all vulnerabilities related to Spring Boot version X and just tell you these are all the vulnerabilities. So how many of you experience this, that every sprint or every cycle you have to update libraries to fix a lot of vulnerabilities? Do that? So you have to end up fixing updating libraries. So do you experience challenge of updating libraries, that broken dependency graph, incompatible changes, can't update, bunch of things, right? Now, if you really think about it, a vulnerability impacts some code in a library. In our application, or say in a third-party open source library, there is some code that is vulnerable, right? Not the entire library. Some function maybe, or some method in a class has introduced a bug which leads to a security vulnerability. Do I still need to update the library, spend all the engineering hours, all the effort, if my application does not even call that function? Right? This is one of the major area of work in next-gen software composition analysis tools. This feature is kind of called reachability, but this idea comes from compilers. Right? The idea is that tools like VET will perform code analysis, parse your source code, as well as the source code of all the libraries, because it's easy to identify direct calls. Say you are using OpenSSL library and calling a function in OpenSSL library. It's very easy to identify that and parse and look for function calls and find that. But suppose you are using a library, which in turn is using another library, which in turn is using another library. There is a full tree or a chain of call graphs, as we call it, coming into picture, right? Even then, ultimately you need to make a decision whether you should spend the time on upgrading a library. It's not easy to upgrade all the time. It requires effort. Should you upgrade? You should upgrade if your application that you are working on is actually vulnerable. So that is the problem that we are trying to solve with VET's reachability analysis capability. We have some ability to parse through source code. We use tree-seater library to parse source code. We can build the entire import reachability graph right now. So for Python application, Python-based application, we are also working on other language support. We can build a full graph of import reachability using which you can identify whether your application ends up importing certain Python module, right? Not just directly, but even transitively across all the libraries that exist in your application, right? We are working on the function reachability as well. What I mentioned that some function is vulnerable, right? Not the entire library. So we are working on that part as well, where we can build a call graph at a part source file level, stitch them together across all the dependencies that you have and build that large call graph, and then find paths. Is basically reachability, right? Whether your application reaches a vulnerable function in some library, right? So that is one of the important, I would say a high priority milestone, but it's a very hard problem. So if any of you have experience with code analysis and want to contribute, please come talk to me. I would love some help there. Another problem that we solve in VET is many a times VET reports that this particular library has a critical vulnerability. Developers who are responsible for fixing, they will come and say that I am not even using this library. I don't know. I have not defined it in my build.gradle or package.json or pom.xml. Nowhere I have defined this library. Then why is VET reporting this library, a vulnerability in this library? That is because when you add a library dependency, these libraries also depend on other libraries, right? So there is a complex network of libraries, or as they call it, transitive dependencies. In order to handle that scenario, what VET does, VET tries to reconstruct the full dependency graph. It adds relation. It say, for example, it detected a full list of, say, 200 libraries in use in your application. So it tries to reconstruct the relation, build the full graph, and trace transitive vulnerabilities in transitive dependencies to its top level dependency. Which dependency actually introduced a transitive dependency and in what level. So what is the result? So this is really the capability that VET has, but the result is something like this. If you use VET and if you use this group by direct dependency, VET will group all the vulnerabilities found in non-direct or transitive dependency by its direct dependencies, so that you can update only the top level dependencies that you as a developer control, and that not always but many a times will lead to upgrading the full dependency chain, right? It will lead to updating the vulnerable version of the transitive dependencies as well. So that is the goal of this particular feature. So in general, while we spent a lot of time in identification related things or improving identification, say for example you added a library dependency in one of your manifests like say pom.xml or package.json, and at some point in future you removed the code that uses that particular library. A lot of tools will still find or still consider that your application depends on those libraries and still report vulnerabilities in that. One of the things that we are working on in VET is actually look for code evidence, like actually look if a particular library that you have declared as a dependency is actually being used in your code, right? So the goal is to reduce the noise, actually give you the vulnerabilities related to, open source libraries that are relevant for you, so that you are not, bombarded with hundreds of such issue, which is a big problem today for this class of tools, which leads to, only identifying problems and not fixing that. So all of this together is kind of leading to the changing focus of VET more towards the fixing side of things. So yeah, I think VET is an open source project. It's being actively developed. We do have a very small community of contributors and people who contribute code. We are actively working on the reachability analysis that I mentioned about code analysis to reduce the number of vulnerabilities and all these things. If you are interested, we have a community booth upstairs, so please come and talk to me. Very happy to talk about the challenges that we are solving in the open source security ecosystem related to how you can consume safe and trusted open source libraries in your application. Yeah, thank you so much. I would love to answer any question. We still have some time. Would love to take any question if you have.
Any questions?
Hi, I'm Shiv. How different the wet is from dependable bot?
Sorry, from?
Am I audible?
Yeah, yeah.
Okay. My question: how wet is the product is wet, and how it is different from we have a dependable bot?
GitHub's Dependabot,
Yeah.
you mean, right?
Yeah.
Yeah. So I think Dependabot primarily looks at two attributes. One is vulnerability and version updates, like version drifts. So vet looks at more data, like it allows you to really vet open source packages based on a lot more data, like OpenSSF scorecard, popularity related data, maintenance related information, bunch of things. And secondly, one of the unique thing about vet is really the policy language. You can define what is acceptable to you, right? The problem with security tools making decisions for you is that may not be relevant for your security needs. For example, Dependabot will probably raise a pull request even for a BDM or low risk vulnerability. You may not want that. You only want to care about critical vulnerabilities, right? So that is one thing which is different in VET, the policy driven approach. And second thing is that VET has a lot of focus now on code analysis. Like VET, we are trying to solve the reachability problem. We are actually parsing your code and trying to find out whether a particular vulnerability is relevant for your code and not just related to the version of the library that you're using.
Got it. But every organization widely using dependable bot because it's part of the gate offer. My question again, if it has a better features, so why still many organizations not aware of WET?
Dependabot kind of is aimed at solving the problem of dependency upgrade. Like if you read GitHub, I think they created that to build this habit of continuous dependency upgrades, right? So that you stay fresh. But you can check GitHub has a suite called GitHub Advanced Security. Under that, they have another product called Dependency Review, which is kind of towards what VET does.
Got it. Is there any plans to have a contribute together? Dependable bot and VET could be.
No, I don't think so. VET has a kind of different direction. VET's direction is more towards code analysis, reachability analysis, those kind of things, and more towards fixing now, because that is a larger problem. Finding, if you look at last 10 years, most of the security tools have invested in identifying issue. Fixing is hard. Right, so VET's focus is kind of towards that, how to help mitigate the issue, because any cybersecurity investment actually gives you the value when you fix the risk, then the risk is mitigated. And that is the hard part currently.
Got it. What is your strategy to increase your wet to be more accessible to the wider communities?
Yeah, just talk about where show the value, and be open to features which the community needs. Like if you look at the last couple of releases, whatever we have shipped is specific ask from the community. Apart from code analysis, we mostly build features which the community asks, like this group by dependency I showed, right? That is a specific ask from some company which is using wet. So we are very open to feature requests that helps real life teams who use wet, as long as it aligns with our goal of reducing false positive and fixing.
Got it. And you also have a commercial version, or it's purely?
We don't have commercial version currently. It's entirely free and open source. We have plans to build a commercial control plane for wet, which allows you to deploy wet at scale and manage policy centrally. Wet is always going to be free and open source.
Thank you.
Thanks. Just to repeat, we have a booth upstairs. If you are interested in learning more about wet or want to contribute to any of these problems I spoke about, please come talk to me. Thank you so much.
So everyone, our next speaker is Harish Babuvi, a full-stack developer at Jukebox and a self-proclaimed nerd with a passion for programming, video games, and history. He has found a way to blend all these interests, and today he's here to talk about the fascinating intersection of technology and nostalgia. He will be taking us through the evolution of retro game emulation from the early days of reverse engineering to today's open source tools that help preserve and restore these classic games. He'll share the journey of how old games are brought back to life and the challenges faced along the way, including the murky legalities involved. His favorite Pokemon starter is something that I relate with as well. He's also a Charmander guy, so I'm really excited about this talk. Also, while we set it up, this is again a reminder that we will be having lightning talks after lunch here. And if you want to propose a lightning talk, you can do it on the whiteboard outside. Lightning talks are like really short, bite-sized talks if you want to give about anything, any topic you are interested in or want people to know about. Sorry for the slight delay. We are ready for the talk.
All right. Hey guys, my name's Harish. I've been a gamer since I was 7 years old, okay? And I'm here to give you all a small glimpse into the world of video game emulation. So let's start with a few games, where this should begin. Now, to anybody who doesn't recognize this, right? This is Super Mario Bros. It was released in '85 for the Nintendo Entertainment System. This is Final Fantasy VII, released for the Sony PlayStation 1, one of the greatest RPGs of all time. All right. Now, the common thing between these games is that they were originally released for consoles. In fact, they were never meant to be ever released on PCs. But we do play them these days, right? Okay. And the reason you're able to do that is because of something we call emulation. Now, this is the formal definition of what emulation is, okay? But if I want to put it simply, say every time you used a virtual box to install an OS on your Linux or your Windows to make it work, right? You are essentially emulating. How? Because the virtual box software is essentially acting like a motherboard with its own RAM, processor, and storage, so that I can install another software on top of an existing one, which should not be possible. That's what emulation helps you to do. And with the video game emulation, right, what you're essentially doing is that using software, you're replicating console hardware in order to play the games that you can't on PC. Now, the thing is, my first encounter with video game emulation, right, started here. All right. Damn, it's nice that a lot of you recognize this. I was in high school, and I wanted to play Pokemon, but I could not afford the Game Boy Advance. I was wondering, how do I do it, man? Do I save for 2-3 years before I can get my hands on a second-hand one? And then my friend is like, Harish, why go that far, man? You can play it on your PC right now. I was like, wait, what? How? So he's like, I'll show you after class. So school's over. We go to his place. He shows me how to download an emulator, download a game, load it in. And 2 minutes into the game, I reach this point where I have to choose my starter Pokemon for Pokemon Crystal. The next time I thought about how I was even doing this emulation, I was 120 hours in and I had 100% completed the game. That's when I stopped to think, wait, how am I doing this? This game was never released for the PC, but I'm playing it. Okay, so how is this possible? So then I learned that what I was using was the Visual Boy Advance emulator. Using that, I could play any game that was released for either the Game Boy Advance or the Game Boy Color. Now, first thought was, what the hell is an emulator and why is it letting me do it? So I was like, okay, I had to figure this out. And you know what? I started to take a deep dive into what emulators were and how this all started. Now, if you're starting a deep dive like this, right, you always have to need a starting point for all of this. You have to start somewhere, right? And with video game emulators, the place where you start is this, the Chip 8 emulator. All right, this is the hello world of video game emulation, guys. This is where you start. Now, the first time I built this, I got to play Space Invaders and Pong. All right. Now, playing it was cool, but my purpose was, how was I doing this in the first place? Is then I realized that I was essentially writing software code to replicate a Chip 8, which was essentially an 8-bit microcomputer from the 1970s. I was writing software to build an 8-bit microcomputer using pure software on my system in order to play those games. And this emulator is replicating an 8-bit microcomputer, which is, let's say, 1,000 times less powerful than any system you have right now, including your mobile phones. It is. All right, but it got me thinking. Okay, I managed to do this because I had access to a free code camp lecture that explained the whole thing, step by step. How did the first guys do it? I mean, they had nothing to go on, right? They didn't have any data sheets, spec sheets, and so on. All the consoles were proprietary, and no company was just going to give it out. So that raised a quick question. So I wanted to take a look into that. Okay, now, video game emulation, right, started in the 80s, but emulation as a concept has existed since the 60s. All right, because in the first place, when emulation was originated as a concept, right, the idea was to replicate hardware systems on software. And these were for research purposes, military purposes, all of those things. That slowly evolved to the civilian side of things for commercial applications like sound analysis, image recognitions, and so on. Now, video games, it picked up around the late 70s. But a proper video game emulator did not emerge until 1985. Reason being that no desktop system was powerful enough to replicate console hardware until then. And even then, they were subpar. The original emulators had problems. They had frame rate drops. They couldn't render things correctly and so on. But by the end of the 80s, say around 89 to 91, that's when the first proper emulator came out for the Famicom. People got to play Ninja Gaiden. They got to play Superman. They got to play Sonic and so on. All right. So the guys who built these things, the hackers, right, they did a very cool thing. Now, they did not have the help of Google the way I did it. They had to figure out how the hardware worked, how the software was used, how to copy the games from the physical cartridges onto their systems in a file format that could be supported. They did all of this work. So essentially, they had to build the emulators, build the tools to build the emulator, and establish file formats for the game files, specifications, and tools to make the game files also, to copy them from the physical cartridge to your system. They did all of this work because they just wanted to see if it was possible, and I mean it, possible for me to play those console games on my PC. And at the end of it all, they went onto the internet, they uploaded everything, the source codes, the build tools, the asset creators, the mod kits, the script engines, everything online. And they were like, look guys, I built something cool. We had fun with it. So if you like to have your own fun, right, take it, use it, and if you can, right, contribute however you can, or build your own, which is the essence of open source. And these guys did it purely for fun. These original hackers, the reverse engineers. All right, now they started this purely for hobby and sharing purposes only. Even when they put it out, right, they weren't expecting anything big. They were figuring that, okay, other gamers is going to download them. They're going to make something out of it, maybe emulate a few games. They figured that would be the end of the line. But the gaming community, the other gamers, right, who discovered this, they decided to take up the challenge / invitation and decided that, okay, these guys emulated these things onto computers. But if this is possible, what else can I emulate these games on? Is it limited to only desktop PCs, or can I do it on any other hardware? And they succeeded quite magnificently because, right, that's where the origin of this meme comes from. Can it run Doom? It's nice to know you all recognize this because, as you all know, right, Doom is run on everything these days. You can run it digital calculators. You're running it on your fridges, microwaves, the display panels on your Macs. In fact, I recently saw a nice YouTube video where a person managed to take the 2D Doom game, turn it into a 3D techno display. I'll share the link if you guys want it, but it's actually pretty cool to watch. Now, all of these guys, right, here's some of the names for it. These people, none of them, not one, they monetized any of their work. It was one of the coolest things ever. They put a lot of effort in and they open sourced all of it because they wanted everybody else to have the fun that they had. All right. Now, here's the thing, okay. Once anything becomes popular enough, it eventually attracts public attention, which is the same thing that happened with the emulators as well. The companies, the game publishers and developers who took notice of this movement, right, at that point they realized that, wait, PC is a market, right? Yeah, there's millions of dollars have been lying on the floor. Time to pick it up. So what did they do? Once the 90s, right, say the second half of it, they started releasing all their console games to the PCs. All right. Metal Gear is a good example. Doom is a good example for it. These Mario games, Mario Kart, all of them. All right. But the thing is, the consequence of that was the hackers, right? They were like, wait, the companies are releasing all the new games to the PCs. So why bother trying to keep emulating the new ones? Instead, let's go back to the older games. We emulated some of them, but not all, right? Let's go back. Let's find all of them. Let's put them up as well. At this point, they ran into a small problem. All right, because when they started looking for the older games, it turned out that many of these older ones, the files were not around. The companies didn't have the source code for it, or the physical cartridges from which they could copy the files, right? Were ruined, missing, corrupted, any number of things. It hit them then that all of these games, right, that they were enjoying since their childhoods, they could vanish one day. So the community decided that right then and there that, you know what, I am not letting this get buried in some graveyard somewhere. It's going to be around for as long as I keep it so that others can enjoy it as well. At that point, they transitioned from being hackers to what I'd call digital archaeologists. And they succeeded brilliantly. All right. They found every single game they could, including the abandonware and shareware demos. Games that were nothing more than a single file on a single CD shared in some magazine. They found them, they put it online onto a library and said, here's the file, guys, download it for free, please have some fun. And if you can, share it with anybody else who wants it as well. They succeeded beyond all, in fact, beyond anybody's expectations. Even to this day, you can still find games that originated in the 60s. In fact, recently, thanks to one of these libraries, right, I found the first, in fact, you could probably call it the first RPG ever, built in 2D, and it was made in 1973. They did it. And I got to play it, and I saw that many of the new mechanics that I use in RPGs, right, originated in 1973. It was brilliant to see. But, right, one of the problems here, something that gets ignored in the whole thing, is that when this effort was started, right, nobody had any permission from the companies. Okay, they didn't have permission from the console makers. They didn't have permission from the game publishers or the developers. But they did it anyway. They put it up online and so on. Now, obviously, the companies are going to look at this and be like, wait, those are my games, those are my consoles, and these guys are undercutting my sales. So I have to take action, right? Now, the action they took ran a full spectrum, as you can see on the screen. All right. So if you are starting from the bad news side of things, right, you have Nintendo. All right. These guys have been active, like since the early emulation days. They've been very active at shutting down any single project they could, whether it was emulating their consoles, preserving their games, copying it. It didn't matter for any reasons. If they could find it and they could shut it down, they would. To them, it didn't matter if it was only for fun or what. It undercuts their profits. They want it. Now, on the other end of the spectrum, I'd say relatively good speaking is Bethesda. What these guys realized is that gamers are guys who are willing to go the extra mile to enjoy their games, thanks to the emulation thing and so on. So they were like, okay, I don't want to release my source code completely. They didn't want to do that, but I still have to take advantage of it. So what they did instead is, they took their games and they built it in a way that was easy for gamers to edit it. They still make the course open source, guys. Please understand that distinction. They only made their games easy enough for players to edit and add content to it. All right. In fact, they did it so well. All of their games, the most successful ones, work because they are very, very moddable. In fact, it's the reason why Elder Scrolls V Skyrim was re-released 4 times. Okay, Elder Scrolls Special Edition, Elder Scrolls Anniversary Edition, Elder Scrolls Creation Club Kit. And they made profits every single time. And there is still an active community adding content to it every other month. In fact, if you want to take a look into it, right, check out Beyond Skyrim on YouTube. They are a modding community specifically for Skyrim who have been adding new maps, regions, content, missions, games, what you name it, for the past 10 years. And it's still ongoing. Now, there's a small middle ground here, okay? Blizzard. All right, now I'm hoping a lot of you know about Warcraft and so on. Some of you might have played their games. Now, here's the thing. Blizzard didn't choose to go the Nintendo route or didn't go the Bethesda route, but they decided that, okay, let's take a middle ground. People gamers are willing to go the extra mile to play the game. So I'm not going to make it too easy, but let me give out map creators so that within my game, they're able to build their own maps and so on. Maybe script up a few sequences and cutscenes they might like and play games. It was still limited, but they allowed players to make their own fun. Now, this was revolutionary when it first came out and it blew up. There were LAN parties, there were competitions, there were all of these things. Now, in the midst of all this, okay, now this was one of the really cool parts about open source, all right. One of the World of Warcraft players, a small teenager, he built a map mode on Warcraft. It got really popular and people really liked the way he made the map and the mode and the rules and everything he set in place. So he decided that, okay, everybody's having fun with it. He took the map, he released it online, saying that, guys, here's the file, do whatever you like with it. Now, people across the community members picked it up, you know, they made their own changes to it and so on. But two of them picked it up, they decided to do something with it. They liked the map mode so much that they took it, they built a game of it, which eventually evolved into one of the biggest multiplayer esport events ever. How many of you guys recognize this? That's a good number. Dota 2 is one of the largest multiplayer games in the world and one of the biggest esports events in the world as well. And this started as a free map mode in World of Warcraft by a teenager who was having fun and wanted to share it with others. That was, let's just say that I was laughing for a good 10 minutes when I learned about it. So you guys have seen the legal problems that emulators and so on face, okay, so far. You've seen the way companies have embraced it, denied it, they've found middle grounds. Now, the 3 examples I've shown are not the full spectrum, okay, there are still all kinds of responses, but I believe they encompassed the spectrum broadly speaking. But the more I delved into it, right, the more I realized that none of these hackers, right, who build the emulators, they never truly monetized anything they did. Yet the companies keep going after them. So my personal opinion is that was not that nice of them because your player is building a community and keeping your game alive for 10, 20 years. And yet you want to keep shutting things down. Why? In fact, the guy in the photo, right, he's Frank Cifaldi. He's the founder of the Video Game History Foundation. And he was also the leader of Eclipse. They were a company that specialized in video game restoration. You name a game from the 80s, 90s, 70s, whatever. They specialize in finding the cartridges, the consoles, restoring the game and the console, and getting you a software copy so you can play for it. All right, and he had this brilliant quote I loved. All right, let me just read it out to you guys. The hackers preserving games for future gamers, right? We didn't call them archivists. We didn't even call them digital archaeologists, like how I name my talk. We call them software pirates. In fact, they're still called that to this day. And yet, these are the same people who have not once, sold the games for any amount of money, keep adding content to it, and keep the game alive far beyond what the companies ever will. All right, so my only hope is that, once you guys, go home today, right, download one of these emulators, maybe pick up one of your old games. It could be Mario, it could be Ninja Gaiden, it could be Rayman, it could be Medieval, it could be Legend of Zelda, whatever it is. Download an emulator, download your favorite game, plug it in, play it for however long you like to. And as you do, right, just think about it for once. You are able to do that today because a couple of people 30 years ago wanted to find a way to have fun and share it to the rest of the world. Now, if this is not open source, guys, please tell me what is. All right. Thank you all.
If anyone has any questions, let us know. There's a question here.
Yeah, so I finished Chip 8, so it was too easy, like I finished it in a day. But then I went to try to emulate Game Boy. That there's a lot of documentation to read. So is there some middle ground between Chip 8 and Game Boy, which is easy to emulate?
That one, you're actually looking at the NES emulator, SNESX.
Okay.
All right. So it's basically the next ground after chip 8. You emulate this one. Let me just move the slide up. Okay. You'll be emulating this next. Okay. So your first game after that, you're going to be playing as Mario Bros. All right. This is the middle ground because GBA is actually complex. People don't really realize how complex it is until they get into the source code, but it is. So this is the middle ground. Although you could also try emulating the Atari 2600, the Sega Genesis, or the Sega Saturn as well. They are also middle grounds. It's just the SNES is more popular. So you go from chip 8, then you go on to the SNES, then you go on to GBA, and from there, if you're still, you're still not tired out by trying to look through all the documentation, you can move on to Citra. It is an active emulator for the Nintendo 3DS. From there, you move on to Dolphin, and from there, well, I haven't touched the PlayStation emulators yet, so I can't really tell you much more.
Thank you.
So I wanted to ask that, what do you think about the recent cases from Nintendo seizing down Yuzu and etc.?
That one, I think they, personally speaking, okay, in my personal opinion, they jumped the gun on it, okay? Because Yuzu, the emulator for it, they very specifically made sure that their emulator would only work with games that you physically bought. Because you couldn't just download the file, load it into the Yuzu emulator and play it. You had to buy the game from the store because it will also generate the perfect keys for you. You had to copy those keys into the emulator. That would verify to ensure that it is a valid copy and then let you play the game. But Nintendo is known for jumping the gun, guys, so...
So what do you think about, like, will GB and DS emulators also be gone?
If they were going to be gone, right, Nintendo would have shut them down 20 years ago. But since they're still around, right, let's hope they're still around, man.
So a lot of some paid emulators are now free, DS and GB emulators, due to this scene. So guys, if you have some DS emulator, now it's free. So download Drastic. Drastic's free now.
Sure. Although if you're looking for a DS emulator, right, there's actually no cache GBA.
Yeah,
That's a good one.
Desium as well.
Hello. Your thoughts on the recent Stop Killing Games movement from the EU? Or what are your thoughts on that? And also, what do you think about Nintendo? Any certain...
I know exactly what you're looking for, Balo, but fine,
certain
I'll give it to you.
Linus moments you'd like to recreate here?
Fine, I'll give it to you. All right, I'll give you exactly the response you're looking for. Now, for those of you who don't know, okay, there is currently an initiative being run by a YouTuber called Stop Killing Games. It's going on in the EU right now. The essential idea is that once this policy is put in place, right, it ensures that if a developer is going to, say, for any reason, stop his game, whether it's multiplayer or single player game or so on, right, they're going to stop publishing it, stop making it available for purchase and so on. The idea is that they at least release the copy of the binaries, even if not the source code, at least the binaries, so that the gaming community can keep the game alive. Now, it's a very complex thing, okay, especially because you're trying to involve the government. And as Shrisa put it, right, in his talk, when the government gets you involved in the market, their responses get to be very, very bizarre. So it's in the initiative phase, it's only in talks. It's going to take some time. Personally, I believe it's a good thing because there are a lot of games that are multiplayer only that have died off over the years. Because there were no players playing anymore, the company shut them down. All right. But for some of them on which the binaries were released, right, people have kept them alive for a very long time. Good examples I could think of right off the top of my head, right, would be Warhammer, Dawn of War. That's one. Or RuneScape has their own servers. There's another one set I can't really remember right now.
Harish,
Yeah.
but here's the thing though, is when you say that, right, certain games are not built to be done that way. So take something like, say, Fortnite, for example, right? When this law is passed, who does Fortnite? Epic, right? Yeah. Yes. Epic is now contractually obligated to ensure that they continue to support, though theoretically Fortnite will never die, but let's assume that it does, right? So they're contractually obligated to maintain this game for a limited set of users, for a limited set of people. Now, while I agree with the intent behind the thing, execution is where where the Stop Killing Games is failing. Their wording around their proposal is too vague, and as a guy who builds games in his free time, expecting developers to support this game even like post, like, see, companies are not going to kill successful games, right? So, and let's face it, the whole game that led to the Stop Killing Games Foundation also was a game that has been steadily dying, and it has a very limited thing. While I do agree games have to be supported, and like, you can't just kill games off, because there are certain old games that very well, like, very like small games that I used to play that are not there out anymore. But expecting the developers to support it post the thing is a little kind of it's too high of an ask, right? So Epic has to now continue to support this, or they have to put in the effort to do this. And my point here is basically stop killing games. While the thing is good, they're being incredibly vague when it comes to how they want stuff done. So my biggest worry is when EU passes this, if they do, and they've been very what's the word I'm looking for? Antitrust these days, right? If they do pass this, right, it sets a precedence that will echo into a lot of things, including what we do, and even though this might be in web dev, this might set a precedence for everything. So that's my thing, right?
Okay.
So I don't think anyone here disagrees with the notion. It's just the specific implementation that I'm worried about.
No, I agree with the implications as well, because there was a follow-up statement released regarding the same thing, explaining clearly that no, they do not want the developers to keep supporting the game beyond their life cycle and beyond making whatever losses they want to. The idea was they were going to shut the game down because the people had bought and paid for it. At the very least, release the binaries so that the community supports it. Because after that, they don't want any obligation following the developers. They don't want them to release maintenance updates. They don't want to release some cycles, content, nothing. At the end of it, if they are going to stop, hosting the game by themselves, all right, we get it. But please release at least the binaries if you're not going to release the source code so that we can maintain it going forward. That's where it is, because there's actually a good example where this would have been useful. Because, there was a recent racing game. I can't remember it right off the top of my head, okay? Thank you guys, The Crew. All right, it's a racing game. It had both single player and offline elements, all right, to it. Sorry, single player and multiplayer elements to it. Now, because they shut down the multiplayer servers, the single player mode also you couldn't make it work. Why? Because they tied the whole thing up, even though there's a single player campaign. All right, so Stop Killing Games is trying to address that now. I agree, a lot of content is pretty vague and it needs to be worked on before it goes anywhere, but please remember, it is still in its grassroots phase, which means that you have the power to actually go, talk to these guys, make sure the wording is tight, so that it works for both gamers and developers without turning into another, a word not fit for polite company, before it turns into a mess like anything the government usually does. I do agree with the intent, Balu, and I do agree with the implications, but there is work going on to make sure it's better. And if you're interested in it, right, you do have to apply. You know what? Speak to the guys, get the wording right and everything.
Excuse me, now, two things. Emulators are fascinating tech, and it is awesome how digital archaeology has come about, and I personally believe that it has a very important place in it, but FOSS United does not endorse piracy in the general sense. And also, we are over time. There's lunch outside. If you want to go, you can go there. If you still have questions, we can stick around and keep at it. And it's all optional, yeah.
Definitely. Adding to his disclaimer, I am definitely not encouraging anybody to go onto an emulator site and download an emulator and play a game today. I am definitely not encouraging anybody, okay?
Okay.
Guys, just a quick reminder, this is a lightning talk. It lasts 10 minutes. So if the speaker takes more than 10 minutes, you can take the questions outside the hall.
Hello. So yeah, good afternoon everyone. I'm Arpit. I am pursuing my PhD in wireless networks and distributed systems. So I'm working on a 5G based setup, an open source 5G based setup for my research. And today I wish to talk a bit about network slicing and what we have implemented in our lab for our, it's kind of a proof of concept that we have implemented that could be utilized, for enterprises basically. So how many of you know what is a network slice? Okay, 1, 2, okay. Okay, how many of you know what is a virtual machine? Probably everyone knows. So how does a VM function? Correct. It is splitting the resources of a host machine. So what essentially happens in network slicing, we are splitting the network infrastructure into slices. Okay. So the underlying infrastructure, for example, in this scenario, if it's a 5G infrastructure, we'll be splitting the 5G infrastructure into various network slices that could be utilized for, let's say, enhanced control, or it could be utilized for providing additional quality of service or dedicated quality of service, or it could also be utilized to provide some dedicated security. So in this project, what we have used, so on top, what you are seeing is the control plane. So how many of you are aware of software-defined networks? Software-defined networks, okay, fine. So software-defined, in a nutshell, if I say, so software-defined network will split your network layer into a control part and a data part. So in 5G terms, we refer to it, the data part as the user plane, and on top we have the control plane. So on top, whatever you see is nothing but a microservice that is built using Docker Compose. We are using containers for every network function. That is a different thing. We are not going to discuss the functionalities of each and every network functions on the top. What essentially I wish to discuss, how we have integrated open source based SDN to use a network slice. Okay. So as you can see on, if you go to the down part, do we have a pointer by any chance? This is a pointer? No? Yeah. Oh, okay. Yeah, I got it. So left side, if you see, we have two different user equipment that are mobile phones that we have used. You can even use a simulated user equipment if you do not have a mobile phone. Along with it, we have a radio head that we are using a USRP B210. So that's, again, if you do not have, you can use a simulated version, because this equipment is only going to cost you. Otherwise, everything else is deployed just by using open source softwares. Okay, then we have this SPGWU. It acts as your user plane. So whatever data is coming from the user equipment, that hits the SPGWU. Beyond this, what we are trying to come up with, OVS and REW. So OVS is Open vSwitch, which will utilize Open Flow protocol. So Open vSwitch is, are you aware of the flow tables? How many of you are done with engineering courses? Essentially completed your engineering in computer science or electronics? How many of you? Rest, you all are still pursuing your, okay, into your, no, of course. Okay, so how many of you have completed 3 years of your engineering? At least 3 years, 3 years and above. Okay, so you would have studied, the role of flow table will be to just forward the data. Just in the way routing, you set it up, the routing table, and you have to, you decide the flow rules. Here the best part is, because as I mentioned SDN, so the flow rules are segregated from the actual flow table. So this OVS just implements the flow table. How the flow table is designed, how it is programmed, those things are managed by this REW controller. So REW controller manages OVS switches via Open Flow protocol. So what we essentially did was that, if you can see on the left side, we have mobile equipments. So we picked up few set of IP addresses of mobile phone. So again, this IP address allocation is also done by us. So we had set up a DHCP within this SPGWU, and we were able to allot IP addresses to the mobile phone. So a set of IP addresses that should be allowed to access my server, the enterprise server. If I am not specifying those IP addresses, it will go and hit the standard internet. Okay, so the benefit of using this kind of setting is, let's say if you're how many of you are working in, working? Okay, so you have certain rules that you cannot access particular websites, or let's say not, sometimes even you don't get to access YouTube as well. So you are restricting to access the YouTube server. Okay, now imagine an organization that wants you to access just a particular set of services that are hosted within the organization. Okay, so this is a solution, and just to remind you all, this all is coming from a wireless perspective. So in wired and in standard IP-based networks, you have multiple technologies, like you even have VLAN as well. But we are talking about network slicing in terms of a wireless network, let's say a 5G based network. So these devices support a 5G network. Now, when we wish to restrict a set of users to use only this particular server, that means we are setting up, let's say, this pool of users on the top, and only they should be allowed to access the server. So that means we are able to restrict a certain set of users of an organization to access the applications of the, applications that are part of the organization. Rest, they all can use external internet. Okay, so this is what a brief about network slicing. And we are on top, whatever we have implemented, the 5G core, we are using a open air interface, even that's a open source project. Below we are using OVS, RU, everything is open source. The only investment is a host machine where you will be hosting Linux, and then you have mobile phones and a radio head. Again, those things are also, simulated option is available if you just wish to get the feel of it. Okay, so that's all from my side. If you wish to follow this, you can fork this Git repo as well. I have the Git repo with me, and I think that's all from my side. So, okay.
We still have time, so we can take one or two questions.
Yeah, so this is the repo. It's called 5G OVS slicing with the organization 5G UCL IWT. You can take it from me separate, after the talk maybe. Any questions or anything from your end?
Any questions? Okay, thank you.
No, fine, thank you.
Do you guys want to do something cool? So our next talk is by Nemo, and he's going to be doing something cool.
Hello. Hello. Yes. I'm going to be speaking about doing something cool tonight. How many of you saw this QR somewhere? Very few. How many of you did scan it? Okay, so I've been sticking this QR all around IndiaFOSS here and there. So you might have seen it. If you haven't, try to look for it. But if you did scan it, you would have gone to a site called blr.today. blr.today is an open source semi-curated event calendar for Bangalore. Open source in the sense the code is public, the data is public. It's semi-curated, which means I'm trying to create a calendar that is somewhat curated algorithmically to decide which events are good versus bad, and there's some judgment involved in that. And then I let those judgments curate future events as well. Event calendar, which you can subscribe to. Calendars are great, and it's Bangalore specific only. I will show a quick demo. If you'd scan it, you would have gone to a site that looks something like this, with a banner about IndiaFOSS. It shows you all the cool events that I think are worth attending today, tomorrow, and so on deep into the future as well. These are all sourced from all across the internet. We have a bunch of different event calendars, including places like Bangalore Chess Club, Bhago India running events, BIC, Blue Tokai, bookstores, fitness events, etc., etc. We are scraping them from a bunch of different sources and places. This is how a specific single calendar looks. You can change views. You can subscribe to them over an RSS feed or over an email feed. It also tells you where the sources are and gives shout back to all the actual upstream links for that specific calendar. Similar things for underline center. The code is on GitHub at github.com/plr today. We have a website source code. The primary code is around the ingestion, which is how we scrape a lot of events from the internet. There's a list of all the different sources that are there. If you'd like to contribute, we have a bunch of open issues on how you can scrape more and more events. We also have a data set. I'll talk about it. We have a community page where you can create discussions, issues, and help me pick it up more. Yeah, back to the talk. I have some interesting insights about events, which I learned in the making of this. I've been wanting to build this for like 6 years, finally got around to it. One is that most aggregator websites have very low quality events. They're incentivized by the number of events that they list. They're incentivized by the ticketing that they do. And as a result, there's a lot of low quality events that show up, which are essentially regular events, Thursday nights, Wednesday nights, Saturday nights, ladies nights. And these are actually regular repeating events that will show up, but not necessarily maybe of interest for someone who's looking out to go somewhere special tonight. Small and cool events, if you have a small venue, like something like Bangalore Chess Club, or Bangalore International Center, or other different venue hosts and organizers, they will not always list their events on, aggregators like BookMyShow or Insider. They might just, put up something on Instagram or Linktree or their blog, etc. Your calendar app is amazing UX. Calendars take events, which are very semantic things. They have a start time, they have an end time, they can be color coded, they can have venues, they can have travel times. All of those are things that you can attribute to an event. All of that is missed out when you go to BookMyShow and you look at a list of cards. There's no calendar view available on any of the aggregators. So I believe calendar is great UX for events. And the structured nature of events, which is what I was talking about, is typically ignored on all of these sites. So those are my interesting learning insights in building an events app. This is the rough tech behind it. We have an ingestion pipeline that takes in a bunch of event data from a bunch of different sources. This is in GPL3, licensed. It publishes a data set that is also on GitHub under ODBL Open Database license. And then we build out a website from that data set, which is the website source code is AGPL3. So if you'd like to, I heard people talking about it. If you'd like to build Chennai.today or something similar, please talk to me. We use the code freely available, etc. Also want to talk about open standards. If you try to scan this QR code, which I think might be doable, I don't know. This QR works perfectly fine on iOS. It works perfectly fine on Thunderbird. It works perfectly fine on open operating systems like this. It doesn't work on Android. There's a webcal URL which is defined by an RFC. It links to an ICS file, and that pushes out events automatically to your mobile device or your laptop or whichever calendar user agent that you use. Unfortunately, Android doesn't support the standard, so for most users in India, it is inaccessible. However, there are other ways to subscribe to calendar. If you copy your ICS file link and you paste it in your calendar app, which might be Google Calendar or something else, it still works. But I'm really sad that something as nice as open calendars can exist. You can subscribe to ICS files, but it's not supported by the largest operating system on earth. There's also another shout out to schema.org. If you haven't seen it, it's a SEO-based effort to standardize publishing structured data on the internet. They typically track things like blog posts or product information, which search engines can use to show you enriched search results, saying, this product is available, this product is priced X versus Y on different websites. But we can also use to structure and publish event information on the internet, which is what I do. So all the events that our data set is essentially just a blob of JSON blob of large schema.org event objects. And we try to enrich it a lot, including relevant tagging information, including things like, hey, this is a movie. Which movie is this about? It's just they will not show up on the website. You can share it with your friends, but they won't show up on the website unless someone thinks it's curated enough. It's a good event to list.
That's cool. Thank you.
But yeah, this is like a soft launch. I still don't think it is good enough for like a public launch. So consider this a soft, tiny launch.
Do we have any more questions?
Questions, feedback, catch me around. I'm Nemo. I'm happy to talk about events and open data. Thank you.
Thank you, Nemo. You really did build some cool stuff. Our next talk is going to be by Advait Narayan about Intro to Rust and Systems.
Everybody, my name is Advait Narayan. I'm currently a fourth year student. So I saw I'm part of a community called as Kerala Rust Stations. So this is basically, so how many of you guys are familiar with Rust? I'll just raise of hands. Oh, that's nice. So basically Rust, so today I'll just give you guys a brief intro on what Rust is and how is it important in systems programming. Or I personally am not, so I just want to not offend any good Rust people or system developers here. I'm just a student, I'm just learning. So I just wanted to share my interest with you guys and introduce you guys to this topic. So today I'll be going through what is Rust and what is systems programming in general and how can Rust be used in the system programming. I'll just show you a simple example as well. The simple example being a simple Linux shell. So I believe everybody, how many of you guys are familiar with the shell? Oh, that's cool. I mean, I should have obviously expected that. So, but yeah, still, if people don't know, I'll just give you a quick rundown of the shell soon. So this is the small agenda that I had. Don't worry, this is a presentation I had presented earlier. This is recycling. So yeah, so I'll just tell you guys about Rust basic commands, Linux shell and coding time. I'll just show you the code. Quick wrap up and some questions. Yeah. So about Rust. So yeah, so have you guys heard about Rust? So would anyone would like to just scream out loud where they've heard Rust or Primeagen? Okay, that's a good, so yeah. Okay, so do you know any similar languages to Rust? C, C++, Zig. Anybody has heard Zig? Shout out to Zig. Yo, nice. So have you guys lunch also? Lunch is also good, no? Yeah, nice. Okay, so what is Rust? So Rust is basically a systems programming language, right? So I wouldn't call it a systems programming language. What I would call it is a low-level language, right? What is a low-level language? A low-level programming language is something that gives the programmer the control of the system, is what you could say in a simple term, right? So say a programming language allows you to manipulate memory addresses or have interactions with registers, right? These are low-level languages because you get direct access to the hardware of the service. What does that mean? It can either mean two things. One, you can blow your system off and not make it work again, or you can have highly performant, highly efficient applications, right? So Rust is such a programming language which allows you to go deep into the system and have very granular control of the hardware. Next, Rust prioritizes memory safety. So how many of you have used C++ and blown your foot with pointers? Yeah, okay. So people who are C++ developers know about the fact that pointers are a big double-edged sword. They can cut yourself more than you can cut other things. So what Rust does is Rust basically has a system, which I'll get into later. I won't be able to entirely explain the system because it's too long and I'm not have a full idea of the same thing as well. But Rust has a system wherein it prioritizes memory safety. Whatever happens, memory safety is priority. One thing cybersecurity people in here might know that a lot of cybersecurity vulnerabilities happening in operating systems is because of memory leakage. Chrome is eating 8 GB of your RAM because of memory leakage. So Rust is a language that aims to get rid of these issues and make it so that we can have high performant applications. And that nicely segues into the last point, being Rust is a compiled language. It's very high performance. It's used, I'm not, don't quote me on this, but I think it's on LLVM or some. So it is very comparable. The speed of Rust applications is comparable to C and C++ if you write it well. Okay. So let's just run through the basics of Rust programming. Okay, the main things in any programming language. So if anybody is learning a programming language first time, I'll be happy to teach you guys. So the first thing is identifiers. So identifiers are basically constants, variables, and things like that. So again, you can have a lot of types. So say for example, how many of you guys are familiar with Python? That's a dumb question, but again, so Python really does not have types, right? You don't have to explicitly specify types. It's dynamically typed. But like C++ and C, Rust is a statically typed language. That is, you have to specify each and every variable on what type it is and what kind of data it might contain. So a few simple examples for this would be and str, that's an ampersand string. So that's basically like your default string in C, character array in C, and string in like C++. Then integers. So Rust uses the simple but interesting notation to like mention the size of variables. So you see 32, right? So that means it's a 32-bit integer. So if you put f, it's a float. So that's very a simple thing, a simple terminology. So I just showing you guys this because when I show you the code, I don't want you guys to be confused. That's all. It's very simple. You have arrays, you have vectors, the same thing. It's in all the other languages. Next, conditionals. So we have if else ladders, all the same, and match cases. So match case. So one important thing. So I won't be able to go into how great the match statement is, but it is actually great. Trust me. So if you guys like have just like Google around or like see YouTube videos on Rust or like code bases with Rust, match is extensively used for pattern matching because it has many great features. So one thing is it is you can't have non-default statements. All conditions when you put in a match statement must be matched. So like if you have any default condition, it should be written down or it should be taken into consideration. So that itself, so like Rust has a lot of small quirks or like interesting things like this, which help you have like write better code generally. But I also write bad code, don't worry. So again, we have loops. So same thing, and like loops in Rust are actually very similar to Python as well. So it's like very easy to understand. So like we have the in operator. So you can do like for I in this list or whatever. And you can just go through that, and it's very easy to do that. And again, while loops are there. And rather than writing a while true loop and just keeping it going, Rust has just something simple known as loop. So we'll be actually using loop, and I'll just show you an example later on. Okay. And now, this is the most important feature or most important topic that comes up when you talk about Rust is ownership model. Very big disclaimer, I am not going to explain entire detail of ownership model because I will be ranting till like next IndiaFOSS. So I don't want to go through that. So basically, Rust's ownership model is what allows it to have good memory safety, right? So that's what the ownership model does. So a simple example for the ownership model is, so each value has a single owner, right? So if I give the variable x equal to something, that means x is the owner of that value. And so it's similar to the other thing is it's similar to other programming languages. If it goes out of scope, it just gets removed from memory. And another thing is transfers. So basically, if you say x equal to y and then y equal to x, this invalidates x because the ownership of the value 5, whatever is inside 5 is being transferred to y. It's a bit of a confusing thing if you just heard it for the first time. But that's how Rust ensures memory safety. So this is because Rust's model, I don't think I have the slide for that, but the Rust model is that you can have, so I'm pretty sure everybody is familiar with references, or basically it's like pointers. So What Rust states, the philosophy behind the memory safety of Rust is that you can either have one immutable pointer. It's like there is one mutable pointer, or you can have as many immutable pointers. This means that you can have either one, so this itself resolves a lot of memory issues. So like you don't have any issues with like multiple concurrency issues, and like it solves a whole bunch of problems, but introduces a few for developers, right? So I just wanted to share you guys with this, and yeah, let's just get to the Linux shell. I'll just show you the code. So again, if you guys are not familiar, systems programming is basically writing code for the system, like the operating system, and like some examples for system programming tools or like system tools that might be grep or like ls, file directory, file explorers, and things like that, which have tight integration with the operating system and allow the user to make use of the hardware or like things like that to have a very good experience and utilize this hardware. Okay. Do I have time? I'll just wrap it up fast. Yeah. Okay. So, sorry, I didn't discuss. Okay. So, how does an operating system work? I'm pretty sure everybody is familiar with how an operating system works, and how a user interfaces with the system is what usually. So, you have two types of interfaces. It's TUIs and GUIs. So, I'll just demonstrate a simple TUI. So, I mean like a small shell application. So yeah, here is the code for the thing. I'll just put it on GitHub and link it somewhere. I'll put it somewhere. So basically, what I'm doing is just trying. So I'm just taking some input from the standard input, and I'm just using a if-else situation to just see. So there are a lot of good packages in the standard library of Rust. I'm just making use of the standard library packages. I have not installed anything else. I'm just using the standard library packages and making them as a simple shell. Okay. So if you guys want, I'll just send you the code. I'll be here somewhere. You can just ask me. So I'll just show you a demo. It's very cold. That's why my hands are freezing. Okay. So here, what you can see is this just simple command prompt has shown up, like that prompt thing. So what I can do is basically I can just type the command ls. You're probably familiar with this command. It just shows you all the files in the directory. So it's basically the files in the program where that is. That like conveniently segued into the folder structure, but I can't get into it because time constraints. But Rust follows a very simple and easy to understand folder structure also. And then a pretty famous command is pwd, which is what is my current working directory. I also get this from the information using standard library packages. And what else command did I write? I forgot. This is like so long ago. Echo, yeah. Echo. India. It's so cold. India. FOSS. Okay, yeah. And it does echo IndiaFOSS. So thank you guys. Thank you for staying with me. This is Rust in like what? Very quick time. Please do check it out. Do contact me if you want anything related to Rust. I'll help you as much as I can. Thank you. Thank you. Thank you so much.
Thank you, Advait. We cannot take questions, but we can all agree he was a very cool professor. Our next talk is going to be by Kailash Nath on discovery of open indexes. Decentralized open indexes.
Kailash Nath after me. What is this?
You messed up my talk's title. Sorry, this is a proper lightning talk. It's fully unstructured. I don't have a structure to even the flow of conversation. There's no plan. But I want to share this idea and invite critical feedback. It's something that's been mulling in my head, boiling in my head for a while. So the working title is DOID, Distributed Open Indexes for Discovery. I'll set the stage first. So Google has become unusable. That is something that I've been dealing with, struggling with for a long time. The last couple of years, I switched to this thing called Kagi. Google's quality has gone down significantly. Something else changed, which is you have an explosion of LLMs now. LLMs generate great-looking text. So a lot of websites now have great-looking text which has no value, garbage text. So we had garbage earlier which you could easily detect. You would land on a web page, it'd be garbage. But now you have beautiful-looking garbage generated by LLMs. So, and we have the dead internet theory, which is largely turning out to be true, that most of the World Wide Web, most of internet is complete garbage. The signal to noise ratio is really, really, really small. And corporations like Google, massive centralized content discovery indexing platforms like Google, no longer, or they lost it a long time ago, have the incentive to surface the right kind of valuable knowledge to a user. Google surfaces, Google, is this being recorded? Oh, I'm naming Google specifically. I mean, any large search engine, not Google. Let's cut that out. Large commercial search engines do not have, they have all the financial incentives out there to surface links and clicks that deliver financial returns to them. They don't have the incentives to surface links, content on the internet that is valuable to the user. So we are in an era where all of us experience this daily. We are in an era where you can't discover quality, authentic stuff on the World Wide Web via these large centralized platforms anymore. Even on YouTube, which is a discovery platform and a content hosting platform, if you search for stuff, you get a lot of garbage that comes up. Even that is algo driven. So it's becoming practically impossible. And like I said, with the advent of LLMs, the internet is drowning in absolute low quality spam. So I had some of these thoughts recently, and I'm trying to again articulate them. The whole idea of internet search, I think, is coming to an end. The conventional understanding. We've been putting in keywords into Google or whatever other search engines for the last several decades to find answers to pertinent questions we have. Two kinds of searches. One is Q&A, where you ask a question and you need an answer. How old is a certain person? What is the capital of this country? Most of our searches are like that on Google. And then you click through a bunch of pages, you browse a lot of text, etc., then you arrive at your answer. That is because, and that's a very tedious way of doing it, but it's accepted because we never really had the tools to find answers to those questions until now. Now with the advent of LLMs and a bunch of other language models, these models are able to give you synthesized, accurate answers. Now, accuracy is still an evolving thing, it's still questionable, but for me personally, 90% of my Google search queries, I stopped using Google, have just vanished. All my technical questions are pointed at an LLM now. And I get precise answers, or at least a precise direction where to go to. So Q&A, the way we used Google or these large search engines to gain insights or specific answers to questions is going to be subsumed by emerging technology. It's going to be a whole new modality. Then remains general topic discovery. For that, you need a system that still indexes everything that is out there. I want to learn about Michael Jackson, I'll put in Michael Jackson wherever, and I want to land upon a bunch of pages or videos or resources where I can do general discovery of that topic. So topic discovery is going to continue. Now, any agent or any system that suggests, or any agent or system that has to help you discover a certain topic has to have an index of quality resources on the internet. And like I said, the internet is drowning in spam. How do you even get quality resources listed somewhere? There is no centralized list anywhere, or whoever has that list has no financial incentive to put it out there. So the idea was that with these assumptions, our ability as users to trust recommendation engines, discovery systems, topic discovery systems are diminishing fast. We will continue to trust. As humans, we will continue to trust each other's recommendations. A friend might recommend a website to me, and based on the level of trust I have in that person, could be domain knowledge, could be whatever, I will take it way more seriously than some random ad that appears somewhere or a random Google search. Exactly like restaurant recommendations. You can't even trust restaurant reviews anymore. You have to go by people's recommendations. I think this trend is accelerating because of the deluge of nonsense and spam. So with that assumption that search is dying, quality is dying, massive amounts of garbage on the internet which does not even need to be indexed anymore. There's no point in indexing any of this. You needed a Google 20 years ago, you probably don't need a Google anymore. There's no value in it because most of it is garbage. And the element of humans trusting each other, peer recommendations. So the idea is that what if there was a way, like a technical standard? I don't have any technical details figured out yet, it's just a vague thought. What if there was a way where people who were accessing quality content or resources on the internet. Content can be a YouTube video, could be a web page, could be a PDF, could be absolutely anything. Now, hypothetically, take a community of medical researchers who are doing cutting-edge medical research. You know, they spend a lot of time researching stuff, and they amass resources on the internet. What if the links or the content or the things, the resources they've collected were published as an index with certain kind of tokenization mechanism? Maybe something as simple as full text search. I don't know. It's just a thought. In a standard format. And it was distributed over the internet. Now, distribution is also costly. If you have, let's say, collected 50,000 resources, in a certain medical community, and it's in a standardized format, could be an SQLite DB, doesn't matter, whatever. Distributing that is expensive. But we have solutions like BitTorrent for that. So the engineering side of it is solved. Now imagine the medical community, the research community produced a medical index of high quality resources that they've produced. And there are many other communities, individuals, organizations all producing, curating, for whatever reason, resources on the internet and then publishing in a certain open standard. Now imagine there's on the other side you have clients that adhere to these specs for these open standards or this particular open format, where people can write whatever client, could be a web app, could be a desktop app, could be a mobile app, where you can, with ease, with great UX ease, download and consume some of these indexes, and suddenly you have a local index of a certain topic, certain domain, it can be whatever, doesn't matter, with an API client or with a UX that makes it discoverable. I'm not talking about search where you have a large Wikipedia page on Michael Jackson, there are tons of facts, 20,000 words. The idea is not to index every single word and make search happen. That's not possible. The idea is to index that whole resource and tag it to a topic, let's say Michael Jackson, or certain topics like music, pop, etc., etc. So it's very topic focused. It's not body or content or text indexing focused. So you have these clients where you install different kinds of indexes now, and that leads you to discovery of topics. Now, how does it? Forget the technical aspects of it. The human aspect is that over a period of time, some of these indexes, open indexes that are published by different entities, individuals or communities or whoever, will start gaining a certain amount of reputation. I'd be like, you should, if you are into medical research, you should check out that index. You should just download that index. It's cool. It's great, whatever. Now, and there's no app. There's no central platform. There's no app. There's none of those things. What if such an index falters? They start indexing spam or they start injecting paid links. The standard mechanism of human peer review and reputation, like, oh, that index sucks, don't use it. They've started spamming. Now like I said, it's a very vague idea. It's a thought experiment. Maybe many engineering aspects that haven't been figured out. But the pieces are all there. And this is my favorite example to cite. All of us install a browser, then we install AdBlock Plus or uBlock Origin or whatever. And uBlock Origin comes with Easy List. It's a community maintained list used by tens of millions of people. I don't know who maintains Easy List. I know it's a community, but I trust that list. And I've given Easy List the access to censor ads or whatever content on my browser. That is what millions of people do. And there's a high quality community maintained list that can wipe out ads of pretty much all of the World Wide Web. It's the same concept. I wouldn't trust some random list from random website. I don't know what's in there, but Easy List everybody trusts. So the standard dynamics of community, accountability have all been factored into a bunch of people maintaining a list, which is Easy List. So the same thing, but for resources on the internet. Resources, like I said, are web pages or PDFs or absolutely anything, but very topic discovery focused. Now, can this replace a conventional search engine like Google? No, that's not the point. But anybody who even wants to build a search engine ideally needs to have a list of resources to index the body first. If we agree that 99% of the internet is garbage, then it's an uphill battle. Anybody who even envisions to build a new search engine, a Google alternate, now has to index the whole World Wide Web of billions, if not trillions of pages, of which 99.9% is garbage. It's a futile, wasteful effort. And the only way to, again, surface quality resources is curation. Now, it's not that if a human has to sit there and curate and prepare this list of resources. It can be whatever. You can have technology tools, you can use AI. It doesn't matter. What matters is that a curated, large, widely used, community maintained, whatever index exists. Somebody can probably create an index with 2,000 resources. Wikimedia Foundation, for instance, could publish an official Wikipedia index with every single topic in a standardized format with categories tagged, etc., which can go into a client. Somebody could come out and build a client that indexes all of these indexes and then crawls those web pages and build a mini Google. So it opens up a lot of possibilities. And the fundamental problem, the only problem that this is trying to solve, this idea is trying to solve, is that without peer review, without recommendation, without human curation, without large-scale community or user approval, it is no longer possible to trust what you see on the World Wide Web. It's full of garbage, and the only way forward for preserving natural knowledge discovery on the World Wide Web and for surfacing valuable knowledge or valuable resources is some mechanism like this where there is curation that's involved. And I think that's about it. So it's not a search replacement. It's simply a fundamental. It's an alternate vision for building a fundamental building block that can enable knowledge discovery or even search tomorrow, which negates the need for having to scan the whole damn World Wide Web, which is not even possible anymore. That's it. And I'd like to hear critical feedback. So please talk to me or please email me. Thank you.
Thank you, Kailash. Our next talk is going to be on improvising the performance of a chat app by Nikhil Kotari. Do we have the speaker in the room?
There's also a workshop happening on Elixir and concurrency outside Audi 3.
Okay, can you hear me? Yeah. Cool. Hi, everyone. I'm Nikhil. I work at the Commit company. We build an open source app called Raven. It's a FOSS Slack alternative built on top of Frappe framework, right? Pretty much like Slack or Mattermost, right? But it's just got deeper integrations with ERP Next and other Frappe apps. Looks somewhat like this. I know the screen's not pretty clear, but you can sort of assume, right? Like it's a standard chat app. And this was built, we started building this at FOSSHACK last year, so FOSSHACK 3.0. And when we were building this, right, when you're at a hackathon, right, your goal really is new features rather than fixing performance issues, right? You only have 2 days and features take priority over anything else, over performance, over security, whatever, right? So we built that, during FOSSHACK, but even after FOSSHACK, this is what our philosophy was like, right? When we were building Raven, new features always took priority over fixing performance issues that were already there, right? And we came up with a lot of tech debt as a result of that. Soon enough, right, 6 months down the line, we ran into performance problems when we ourselves started using Raven daily, right? There were too many database queries, a huge bundle size. I don't know how many of you are front-end devs over here. You would probably, understand bundle size. And then there was a bad scroll performance on the front end. And I'm going to, show you what the problems were and then how we fixed it, right? But this talk is more about the philosophy of, like, actually building apps that are highly performant, wherein, you really, really need to care about performance, especially a chat app, since the bar has been set so high by other apps that are there. So last IndiaFOSS, we met Vinay Kumar from Zerodha, and he gave us 2 pieces of advice. We spoke for about an hour or so. He gave us 2 pieces of advice, right? One was that when when Zerodha builds, Kite, their web platform, right, they think about each byte of data that is served to their customers, right? And that's why if you want to run Kite, hopefully on a slow 3G network, it would still work, right? And imagine the scale at which Zerodha operates, right? Millions of people logging in at 9:15, trying to place their orders. And the other thing that he told us was think about hot paths in your system, which are essentially what is the most critical thing that you're doing in your app, right? And then you need to start optimizing from there, because you need to know where to start from, right? You can't just say, oh, I'm going to fix the performance issues, but you don't know where to start, right? So he said start from the hot parts in your system. On a stock trading app, it could be placing an order. On a chat app, it would be sending a message, right? So the first thing about fixing performance in your apps is that you cannot fix what you can't measure, right? The really cool thing about fixing performance issues is that you can actually measure performance, right? There are ways to do it. The first thing that we did was bundle size. This was like the easiest thing to fix, right? For those of you who do not know what a bundle is, on front end, if you're writing, CSS, JavaScript, HTML, all of those are bundled, and then you just get a final JavaScript and a CSS file, right? You can also code split that, but the bundler's job is to compile these TypeScript files and other things that you have in your, let's say .vue files, etc. So the bundle size, right, is essentially what gets served to your end customer, right? In our case, our bundle size was over 2 MB. So on a slow 3G network, even loading the app would take about 4 seconds, right? Now, how do you know how to fix the bundles? Like, where do you, go and say, okay, I can save some amount of JavaScript here? Well, there's a site called Bundlephobia. You can search for any package in Bundlephobia, or you can upload your entire package.json file, and it will list out all the sizes as well as the loading times across different network speeds, right? But a better way would be to visualize something like this. There are tools out there for Wheat, which is a build tool, a dev tool. There is a visualization that gives us the entire heat map of all the modules that are there. You cannot see it on this slide, but each box over there is a package, right? So it could be a package to, let's say, a Radix UI package, right? Or it could be a package to copy something to clipboard, right? All of these are like individual libraries and stuff, right? Remember that when you install a library, that library also has other dependencies in them. So you're actually installing not just that one dependency, you're installing multiple. So what did we eliminate? We moved to Radix UI from Chakra, right? Chakra UI is a React-based library. We moved to Radix and Tailwind, so we eliminated all CSS in JS, as well as because it's Tailwind, the CSS that it's finally given out is actually very tiny, right? The second thing we did was we replaced Moment.js, which is what Frappe uses, to Day.js, right? And that eliminated about 800 kilobytes, just like that, right? And then there is, other libraries. So one of the key problems that we ran into was that we were actually installing NPM libraries left, right, and center, right? So for example, copy to clipboard is a very simple thing to do, but we installed a hook for it. So we got rid of that. And then any page component, etc., that you have in your React app, Vue app, whatever, that are not needed by default, right? You need to load it lazily. So in our case, how many times will a user actually click on the add channel button, right, to open up a pop-up? Very few, right? Most of the times you log into a chat app, you're just chatting directly. So we lazily loaded all of those pages and components, and this resulted in a 50% smaller bundle size. So from 2.2 MB to around 1 MB, and this is without the gzip, right? Next is scroll performance. So I'll let you guys judge it. Right over here, see, I haven't added any virtualization. Virtualization, I'll explain what it is. I haven't added any virtualization, but when I move back to the channel, see how much time it takes. Because it's fetching all of those messages and then rendering them one by one, right? So what is virtualization? And we actually tried fixing this problem using that. Virtualization is essentially, let's say you have 500 messages. At any given point of time, right, your user is not going to see 500 messages, right? They're only going to see whatever fits in their browser window, right? So you take that entire 500 message list, you divide it into chunks, what we call as windows, right? And you only render those. So out of the 500, you might only render 5 or 10, right? So that's virtualization, only render what the user sees. And so, regular scrolling, you would render everything. In virtualized scrolling, you would only render the only the items that will be visible, right? So we added in virtualization, and you'll see the problems, right? You'll see the scroll is not smooth, right? It's loading slowly, slowly, slowly. But switching the channels was pretty fast. So it solved one problem, but didn't solve the other problem. Now, why is that, right? Well, it's because, messages are random. Like, the whole point of virtualization is that if everything is of a fixed height and my viewport is of a fixed height, then I can know how many of those rows will fit. And then I can perform, virtualization because I know of a calculation. In this case, heights are just completely random. So you cannot really compute how many messages to render. A message could be an entire huge code block or could be just a hello, right? So how do you virtualize it? Probably, you need to make your own virtualization engine. So how did we fix it? Well, we just went through with, pagination, and we optimized individual message renders, right? We forgot about virtualization. We got rid of all of that. We weren't loading 500 messages anymore, right? Now, in Frappe, right, the most common type of pagination that you'll get is offset based, wherein you say, okay, limit 20 messages after, so you want to get to the second page, you would do offset 20. Then the third page, you would do offset 40, and so on, right? The problem is these queries, right, the way it works in the database is that it will actually, fetch everything and then just discard the data, right? There's a great planet scale video by Aaron Francis on this, right, where, we got this graphic from as well. But, we moved to cursor-based pagination because in our case, messages just need to be ordered by the timestamp, right? It needs to be from the newest to the oldest. So we just went to cursor-based pagination. That is, and with some clever indexing, right, we were able to achieve pagination. The other thing is we started optimizing each and every individual message, right? So look at this message, right? It's got so many components. It's got a left element. It's got this link preview. It's got this header. It's got those actions, those hoverable actions over there. And then it's got reactions over here, right? So messages can be very complex. So how do you figure out what is causing the performance bottleneck, right? Where is the performance bottleneck over here? In any, framework, front-end framework, React or Vue, you will get a tool like this, right? This is React Dev Tools, but you will get a profiler of some sort where you can actually check each and every component and how much time it took for re-renders, especially how many times was it re-rendered, right? And then you can go on fixing the performance from there. So yeah, the things that we did, the action palette is now loaded lazily. So only if the user hovers do we mount it. Earlier we were just, using CSS to hide it. The other thing is that the emoji picker, there are thousands of emojis. So for the emoji picker, we now use a lightweight component. And then everything else, we started lazy loading, right? And for all of these pop-ups, so you want to delete a message, you want to edit a message, there's a pop-up that comes up. All of those were made global instead of rendering in each and every message, right? And then the final, just the hot parts, right? What Vinay had mentioned. So we cache almost everything now. Everything that, that was a database call, we are now caching it. Because in a chat app, the most common thing that you do is just send and receive messages. But everything else, the list of users is always constant. The list of channels is always constant. Who is part of the channel is also always constant, right? Mostly constant. So we cache almost everything that needs to be cached. And then when we are sending a message, we just relied on WebSockets for everything. So WebSockets are extremely lightweight. The connection is, always there. So when you send a new message, right, it goes via WebSockets. When you receive a new message, it comes via WebSockets. So there's no API calls for sending and receiving of messages, right? The way we used to receive a message earlier was that if, let's say, if you sent a message to a channel of 100 people, 100 people used to make an API call to fetch the message, right? And so imagine, that, 1,000 people, 10,000 people, and then your server's just getting 10,000 messages, 10,000 API requests, right? So now everyone just gets a stream of WebSocket events, and that's how the chat interface works. And this actually ensures that our app also now works on slow 3G, right? Which is like at least sending and receiving messages works on slow 3G, right? So yeah, the crux of the talk is really that, performance is something that we usually overlook, right? But now we have set it as default, so any new features that we build, we want it to be performant out of the box, right? And this is something that, like, if you were at a hackathon, I wouldn't recommend doing this, right? Performance or security, they take a backseat at a hackathon. But after the hackathon, like we were, right, maybe switch back to performance mode rather than, building building more features. Yeah, that's it. Thank you.
Thank you, Nikhil. Our next talk is going to be about future of computing from Nilesh.
Hello. All right, I've just put some slides together very quickly. Mop is really cool. Okay, so this is basically part rant, part like some ideas that I've been thinking about. So adding on to what Kailash was saying, it's today's computing sucks, right? It's things are bad, and there's a word of the year that was awarded last year. It's called enshittification, like how products on the web start out nice and then eventually everything goes to shit, right? So here's a quote that I came across. I'll read it out because it's light. It's like a dark forest that seems eerily devoid of human life. All the living creatures and are hidden beneath the ground or up in the trees. If they reveal themselves, and she's talking about humans, right? The real humans. If they reveal themselves, they risk being attacked by automated predators. Humans who want to engage in informal, unoptimized, personal interactions have to hide in closed spaces, like invite-only Slack channels or Discord groups or email newsletters, small-scale blogs, and digital gardens, or make themselves illegible and algorithmically incoherent in public venues, right? And she had this really, really good sort of illustration. So on the top, the public internet is just dark forest, right? Only Facebook and LinkedIn and Google and all the other shit is there. Then on the below that layer, we have cozy web, like closed groups, private channels. And at the bottom of the pyramid is the dark web. It's like 4chan and where you don't want to go. But that's where true humanity actually shows up, right? And there was this quote that I want AI to do my laundry and dishes so that I can be creative, and not AI to take up the creative work so that I can, all I can do is really do my laundry and dishes, right? So today's computing sucks for users. And notice I did not say open source computing sucks, because that part is obvious. Like these are like 6,000 highly technical people, and they still use Telegram for their chat. So, but it sucks not just for users but also for developers, right? You know how platform control and cloud computing and everything has made it really, really difficult for you to build like a really, really good experiences, right? In terms of programming languages, we are still using Python and JavaScript, which are like 20-year-old, 25-year-old languages, and the expressivity that the qualities that the robustness that we want in our software is not available, right? There is the challenge of building on cloud versus on-premise. Nothing is perfect, right? Everything is like has like hacks here, and every like entire layer is just made up of broken pieces, right? And what I want to pose to you is perhaps we are not asking the right question, right? Thinking of users and developers as separate entities is probably the wrong model, right? So there was this blog post, and this is sort of my lightning talk. This is the topic that I want to bring. It says, okay, can we think of coding something like that you do for your, the way you do cooking for yourself, right? So here's an example. Basically, this person wrote that I created a messaging app just for my family, right? This is not a platform. This is not supposed to be a side gig. This is not supposed to be, sort of a Y Combinator startup. I made a messaging app for and with my family, right? It's ruthlessly simple. We love it. Nobody else will ever use it. So it's like programming equivalent of being like a home cook, right? When we say learn to code, we are thinking about, okay, it will get you a job and you'll make money and all. But why can't we think of, the same as, learn to cook? People don't only learn to cook so that they can become chefs, right? Some do, but many more people learn to cook so that they can eat better or more affordably because they want to carry on tradition, So the list of reasons to learn to cook is overflowing, and only some of them have anything to do with the marketplace, right? So when you liberate programming from the requirement to be a professional and scalable, it becomes a very different activity. You don't have to worry about scale, right? You don't have to worry about all the concerns that come with, okay, if I want to make a business out of it, right? So just as cooking at home is nothing like cooking in a kitchen, commercial kitchen, right? So the messaging app that I built for, it won't change unless we want it to change. There'll be no sudden redesign, no flood of ads, no pivot to chase a user base, which is inscrutable to us, right? So this idea is actually finding like more and more uptake. This is a talk by Orion Reed, and he expresses it this way, right? That the topology of software that we have today, we hide the computation behind an interface, which is the human-computer interface, and then that is what we expose to the people. And every time there is some change that people want, they become dependent on developers, right? So this topology actually incentivizes a particular structure, right? Can we shape this future in a different way? Like take hardware, for example, right? I have this piece of shit MacBook, and I broke my screen, and I could not get it repaired in Bangalore. I had to send it to Mumbai. Why? Because Apple puts a sensor, like a lid sensor, and the calibration of that lid sensor is dependent on software which Apple does not give to the official repair people, right? So can we think about, sort of reimagining computing, right? So can we build modular hardware where all the parts are available and, we can replace and plug and play, all of that. So this is a framework computer architecture. It's not available in India yet, but this is going to be my next machine. I'm hoping that. Because I really don't want to buy Apple MacBook from next on, because I'll rather buy a small mini PC that I can carry to office and home, and I can keep 2 monitors. That's much better than having this sort of closed systems, right? Here is a different kind of architecture for building sort of a computational system, right? If we build like a canvas which allows computation and the interface to mix together, and people can build their own interfaces. So no code had this promise, but no code again was hiding the computation behind a user interface, right? So you always hit a ceiling in using no code platforms, and that's when you have to throw it all together and then go back to a proper programming language. So we need to reimagine these experiences. Some aspects of this is essentially combining what is happening in AI. So today, the way we write programs are fully specified, fully deterministic, and they can't handle anything unexpected, right? They are not malleable in that sense, right? So there are 2 levels of thinking about it. One, the user should be able to change the software when they want, and second is the software should be self-healing, right? And it's possible to do this today, right? So this is like a prompt from me to you guys, right? Can we combine the neural computation with the symbolic computation like traditional programming languages and get the best of both worlds, right? We have the large language models available, which is somewhere on the spectrum between the two, but this unification is yet to happen, right? The way we write traditional programs, they are fully deterministic, fully specified, and we want systems that can do the exact amount of rethinking when a unexpected event happens, right? So for example, there's a trade-off, right? On one hand, you have systems where an event comes and they do complete rethinking. And this is basically decision theory, right? On the other hand, we have traditional programs where all the rethink has to be done in advance and they can't react to the real world events, right? Software has to be rewritten. Can we achieve a balance between the two so that the agent or the software does the right amount of rethinking, reconfigure itself, heal itself, and then just keep working, right? And finally, one idea which is, this is Brett Victor's project called Dynamic Land. So computing is very lonely activity. You know, the way we have designed our computers, it's a one-to-one activity. I put my headphones, I go to my sort of cubicle or a corner, and then computing means being cut off from the people around me, right? But it doesn't have to be this, right? We can invent new media, new kind of platforms where computing becomes a shared activity, right? So this is a must-watch. If you like, you can go to dynamicland.org and you can see what experiences are possible, right? So just some prompts for you. These are some of the links. So yeah, there's a blog post called Home Cooked App. This is Oran Reed's talk called Spatial Canvases. This just came out last week, the new website of Dynamic Land, and there's tons of great ideas here. So yeah, that's what I have, and I would love to have a conversation about this. We are having a meetup about related topics this month. So if any of you are building something around this, please come talk to me. Thank you.
Thank you for this talk. Really like the barefoot developers and home-cooked software ideologies. Next up, we have a talk called Let's Demo Our Hardwares. Let's do more hardwares. I honestly, it's probably a writing issue, you know. All right, we are going to have something very dark happen. I mean that only. The lights will be killed, murdered in broad daylight.
Testing in prod, guys. Testing in prod. Okay. So, hello everyone. There's not a lot here, so I think that makes it better. So, anyway, my name is Balu. I'm a part of Absurd. Just to give you some context, we are a bunch of hardware makers, bunch of actually, you know what? Calling us makers would be better because everyone in our group likes to make stuff. I mean, yes, you know, there's a large portion of us are hardware people, but we have a lot of software guys as well. So the main idea behind what we're trying to do is get more people to do hardware, right? That's kind of what we have settled on right now. And we do so by building cool stuff like this and organizing a tiny community where folks can come, like-minded people, we can come, go to each other's labs and just build cool shit, right? What you're looking at right now, you know what? I think Amit here, go on. I think he's the right guy for this. Here, I'll hold him.
Okay, guys, look, I have a black hole. I made a black hole with hardware. You can carry around black holes if you want. It's nice, right? Like, this is just LEDs. But the idea that Balu has is fundamentally true. All of us are makers. Like, we've broken toys. When we started, we used to open things that we shouldn't have. And the idea is we're trying to get people to be attentive about their surroundings when it comes to technology. All the technology that you use right now is made by less than 2% of the population. Open source software is a part of it, Hardware is much bigger. Every light here, the microphone, everything that you're surrounded by, someone made it, and it's closed source. Our idea is we're trying to open source it. One of the things that we're starting out with is we're making projects that are fun rather than utility oriented, like make things with technology that are related to play or related to having something that's not productivity, because there's so much productivity. And one of the most important things,
Guys, we have utility as well. Like what I'm holding on right on my hand is a macro pad that you guys can actually buy from our store. Pretty much everything you're seeing is something. Yeah, that's one more thing I have to add as well, right? Is while we are hardcore open source hardware, we also want to make it so that people can buy and consume this open source hardware as well, which is why, you know, everything you see on the stage. Oh, this is it. Wait. Let's restart the lights. Can you hold this?
if you
Yeah, can you let there not be light? Start the lightsabers on.
Oh, they're all
Turn it off. Yeah, they're running out of juice, guys. Open hardware, right? Open hardware.
ready, switch it on, come on.
Yep. Right?
Say hello to the Jedis.
Right? So, guys, this is essentially what we want to do is let's do more hardware. Let's build cool shit. Oh, should I? Oh, damn. Yeah. And please join our Discord community. We are we're a very active Discord community filled with folks from all walks of life. Please join. We don't have a QR code up, so you'll have to come to us, and we'll give you a QR code that you can scan to join our community. Please join. Like I said, it doesn't matter. We're all makers. It doesn't matter if you're a software dev or a hardware guy or anything else. We encourage makers to come join us, and let's build cool shit. Yeah. I guess we have a little bit of time, so I'll pass it on to some of the members in our team, so you guys can talk shit.
To echo Amit's sentiment, most hardware is a black box. So I'm interested in trying to explain that, demystify that for people, so that people have a general understanding of how the average piece of hardware is put together. In that vein, I gave a talk about this yesterday. It's a e-paper watch that you can put together as a kit. This is my contribution to this gang of hardware, basically. Yeah, that's pretty much it.
So I'm pretty much new to hardware. I build badges. I have e-paper badges. I don't have it right now with me. But I also have a community in Mumbai. So if anyone knows people in Mumbai who'd like to come and talk or just build hardware, please come reach out to us. That's me.
What do you say? So we had no plans on doing this. Ansh asked us to do it and we did it, so we have no plans. So since we have a lot of time, I want to ask you guys a question. How many here want to do hardware? Right? That's awesome. Can you raise your hands a little higher? Right?
Oh, there's a bunch of you. Nice.
Awesome. Please join our Discord and
Okay, someone who wants to do hardware, can you tell me what you want to do? Yes. Don't do that.
So then I recently got a multimeter and I am inching to buy a bunch of relays and put them on the internet. And seeing you guys do this today, I might as well do that and get started.
More people, anyone trying to build hardware, you want to say what you're trying to build and how we could help?
Okay, so I don't have some kind of well-defined idea. It's just I have to start. I thought of starting this small video series, building stuff I'll just tinker with stuff. For example, my LED strip just broken down, so I am like reverse engineering the small IC test with Arduino Nano so that I could change its colors and make it open source. That's it.
So I am a big fan of Tron, and I want to build a Tron identity disk, which is basically a lightsaber turned in a circle. So yeah, I'm looking forward to build that.
Same. Okay, we can actually build that. Yeah, we build that. Okay, next, someone who wants to build hardware. What do you want to build?
So I've been a designer from like last 5 years. I'm into graphics, into softwares, but I think hardware and open hardware is a thing. Come on, guys, all of the hardwares are losing its character. Everything is boxy and all, right? So I think we can bring some taste to it. So that's the philosophy. And thanks to Amit and Balu and everyone in the channel, Discord channel, they helped me get my first 3D printer as well.
Yes, he got a 3D printer, by the way. He joined the community, he got his own 3D
And
printer.
that is because of them. So kudos to you guys. And yeah, that's it. I think I'm still learning designing 3D objects and getting it printed right now.
What does it feel like to 3D print by?
Oh, believe me, it's magical. Imagine you can, think of something and then design it in like next couple of minutes and then print it like next another hour. That's magic. You can do anything.
So the thing that he's sending to you right now, it's called a reticulated 3D print. So it literally comes off the bed as is. Like it's a bunch of different parts that self-assemble off the 3D bed. So you don't even have to assemble it after you print it. Please pass it around. Anyone else who's trying to build something with hardware, or who's built something and they've not talked about it. Okay.
Speaking of things that you want to build, continuing the Tron example, I also want to build the Tron costumes. They had like light, yeah.
Cosplay. Join.
Definitely.
Discord. So please again guys, once again I cannot stress this enough, right? Please join our Discord. Again, this is this is lightning talk in its truest essence, right? So please, if you come to us, we'll share a QR code. Please join, and let's build shit together. Yeah.
Thank you so much.
Thank you so much.
Oh, my capo. Okay, so one of the things that I have here, this is the capo part, basically a square or something. The idea of play means that not everything has to be this spin it, you get it on your finger, and it's in your finger. Very good. Can I get a one? Someone to raise their hand. Come on. Very good. Yes, that. Someone else like to try. I want a volunteer. Nice. Careful. My bad. I'm sorry. So it doesn't always go exactly where you want it to, but that's okay. Keep your hands back. Back to you. Almost. Very good. Complete. But the idea of taking here, slowly getting this back. Old tables. He was a waiter at a restaurant, and he was when he was over at a this was very easy. Let it spread. Stuff like this is we have a lot of productivity. He doesn't care. You're around the mirror. Do things for you. Nobody will give a shit.
Thank you for that entire session. I'm not sure how I would classify it. Next up, we have a lightning talk titled Stun, Circumventing Gnats by Naveen Srinivas. Do we have him? Yes.
Hello. So how many of you have heard of NATs before? Network Addressal Traversals. Right? And if you've heard of NATs, have you tried creating a NAT mapping in your router? Yeah, you have. And what did you create it for? No, but it's to put a service on the internet, right? Right.
Most residential IP problems. It
Yeah,
used to work when I was in
that's
college.
exactly what I want to get into now. So yes, there's this thing called NATs and networks, which pretty much help you put your service on the internet. And the way it does is that you can have your ports being mapped to a particular, you can have your local IP address mapped to a particular port on the external network and stuff like that, right? And I, as a builder, really don't like NATs. And the reason for it is just like a couple of seconds before, I mentioned that NATs are a way to put your service on the internet, but they turned out to be something else in the recent days. So you might think, okay, if you have a NAT in your network, why don't you just create a mapping like I asked him, what did you use it for, and your service is on the internet? You would think that, but no. So there's this thing called CGNAT, which most ISPs these days have started using. The full form of it is carrier-grade NATs. What's carrier-grade? Well, carriers, right in the word, it's for ISPs. But what it is it's a NAT that you don't have control over. So it's a NAT that the ISPs have, and you cannot create that mapping that I just talked about a couple of seconds ago. So then why do these ISPs use it? Why can't they let us have our free and open internet as we would like them to give us, right? Turns out they're cheap. Yeah, ISPs are really cheap. And using a CGNAT helps them buy a single IP address and use that IP address for 65,000 users. And if you're really good with networks, this number right there would make sense to you, because that's the number of ports you can have on any network. So you can use a single IP address and multiplex it to a lot of ports, right? So yes, as I mentioned again, these CGNATs are not under our control. It's controlled by the ISP, and you really can't control it. So in case if there is no traffic that can come into your network and come back to you, how are you getting this content of YouTube, Facebook all delivered to you? Because it is incoming traffic. Traffic is traffic, right? So that's where you have something called stun, right? Actually, no, not yet, not stun yet, right? So that's where you have this thing where the ISPs actually create a mapping for you every time you create a request to YouTube or Facebook. So say you type www.youtube.com on your browser, right? And the moment you do that, the ISPs actually create a mapping for you through which the service can send it back to you. So that particular CGNAT is observing all incoming traffic, and if some traffic comes on that mapping that it just created, it will forward that traffic to you. So now what we can do, we are smart, we are programmers, right? So we will start using that particular behavior of the ISPs to our advantage and start making mappings in the CGNAT even though we're not allowed to, right? And that's the protocol we're going to talk about, STUN, which I think stands for Network Traversals. I forgot the exact full form of it, but it's there in the RFC, doesn't matter. But pretty much how it works is what I just told you. Every time you make a request to YouTube or Facebook, ISP creates a mapping, and the mapping will be a public address that the server observes. So instead of making a request to YouTube, you could make a request to the stun server. So there can be a separate server called the stun server, which its only job is to observe what the mapping is being created, like what the port and the address that ISP has given your traffic, right? So you could take this address and this port and pass it on to your friends or some other computers, which can then now freely send traffic back to your network, and there is no blocking of any sorts, right? But if it's that simple, why am I still talking up here, right? So turns out ISPs are even more cheap than we thought, and there are different types of NAT mappings. So there are 3 wide types. The first one is endpoint independent. So no matter to which service you create a request, right, the NAT mapping will work. So if you make a request to YouTube and your address is ABCD and port of some X, an address, a service which is not YouTube, say Facebook, can send that particular data back to you through that same ABCX. It doesn't matter whom that mapping was created for. And this is the best case scenario. If your ISP is doing this, you can enjoy. You can create any sort of services that you want, and it will just work, right? And the second one is address-dependent mapping, where your mapping differs for different addresses. So there'll be a separate mapping for YouTube and a separate mapping for Facebook, and only the addresses that this mapping was created for can send back things to you. So it can be ABCX for YouTube and ABCY for Facebook, and Facebook can only send things back to ABCY. If Facebook tries sending traffic back to ABCX, it just won't work, right? And the third one is address and port dependent mapping. So not only is your address being unique, even your port is being unique for each mapping, and which is the most restrictive type. And if you have this, you won't be able to circumvent the NATs, right? So is this protocol used? If it's out in the open, why aren't more people using it? Turns out most of us are using it every day. Things that you use like Zoom, Gmeet, stuff like that are using Stun. And this is part of the WebRTC stack, right? So we've heard of WebRTC, which is real-time communications. And that's where I first learned this stun or turn thing from. And what I'm trying to do with it is pretty much implementing the protocol from scratch so that I can start implementing it in my projects and put my things out on the open if I get it to work well. So I think that's the conclusion of my talk. And I'm hoping that IPv6 will solve all the problems we're having. But as of now, IPv6 has its own problems where it has to be tunneled through IPv4 networks and things like that. And if they do create NATs for IPv6, there will be another talk and another blog. But that's about it. Thank you.
Thank you for that talk. Next up, we have OSS Stuff to Scare About by Ram I. Let's give it up for him and scary open source stuff.
Hello everyone, welcome to my lightning talk about open source stuff that you should care about. Now, there's also a slight angle to the stuff that I'm going to talk about, which is that a lot of this comes from some experience that I have in working with open source. By way of introduction, I work with the Linux Foundation. I do open source full time. There's a lot of things about open source that people don't sufficiently realize about, and I thought I'll just chat through these things, and some of which you might already know, some of which might be new to you. Now the first thing that everybody thinks of when we talk about open source is that it's all free. It's free to use, it's free to modify, it's free to redistribute. I can probably make money out of this thing. But what a lot of people tend to forget is that this freedom comes with some kind of baggage attached to it. And so the rest of the talk is going to be about 4 or 5 different areas where I feel that there's a lot of opportunity, there's some struggle, you have to be wary of it. So the first thing I wanted to talk about is the word that comes to your mind when you see this image. It's probably a very common sight around Bangalore, and they're like, license kodi, license kodi, license kodi, every time you get stopped at a traffic light. And so the fundamental thing that matters to an open source community or to an open source project that you want to promote is licensing. And there's so much that's been written and done about licensing that it can feel extremely overwhelming to somebody who's starting off. There's all these different kinds of licenses that appeal to certain people and apply to certain kinds of software and things like that. It becomes extremely hard for somebody to decide, okay, let me put this license and begin there. There's no proper way to decide on a starting point to how you want to do open source licensing. And more recently, we've gotten into all these Terraform versus OpenTofu versus and Elastic changed their licensing very recently, and that was all in the news. And it's a very complex thing to nail down, and it's a very complex thing to maintain in perpetuity and find ways to do licensing well. The next thing I want to talk about is something that a lot of folks in the open source community want dearly, but they don't know how to go about it. And if you can fathom a guess, it's about security. Now, everybody wants their software and their projects to be secure, but people either don't know how or they don't care about it. So it's all about this, and the larger community is not helping. So when you're doing a methodology like DevOps, let's say, it's all about, okay, build this feature, containerize it, ship faster. What's that? Move fast and break things. Please don't. It's nice to say some of these things, but it's not the best to apply. But security is one of these things that tends to slow people down on the day before release or the week before release, where they'll say, go through this audit, and they'll put you through some new team that you were just introduced to 2 days before the release, and now you cannot release because they've not signed off on it. And this is very common in companies that build software commercially, but security has a very peculiar problem when applied to open source as well, in that you're at least forced to go through some kind of security audit when you're doing commercial stuff, and that is really not a thing in open source. And so nobody forces you to think about security at all, and that can be quite a bit of a pain. And while I grew up with this faith that I use Linux, and so no viruses can attack my computer. And now that I've grown up and I work and I write software for a living, I still kind of believe that I use open source and nothing can ever happen to me, but nothing can be further from the truth. It doesn't matter if you're invested in open source heavily, you're still vulnerable to a lot of malicious actors and things like that. Which brings me to another important part of the open source world, which is a lot of software gets built in groups. Almost nobody, maybe except Captain Nemo, builds software in isolation. Okay, so people work along with others. They sort of work on different components that make a larger whole application. And a lot of work in the software world happens through cooperation. You work with people who test your software. You work with people who will help package it. You'll work with people who will help release it. And so the fact about open source that I really like to emphasize to a lot of people is open source software is a very high degree of realization of this particular paradigm. It realizes this paradigm to the fullest, in that it's a community driven effort. It's a community powered effort. You need a lot of people to sustainably work with open source. And shameless plug, I have a few more minutes, but we're doing a panel discussion about this very topic soon after. So if folks are interested, to join that. But the idea that the community is what helps build and keeps the momentum going in open source is something very important. I cannot stress how, I mean, what the value of community is, but it's, I think everybody understands how it keeps people going. But there's also a challenge that comes when you bring in people to work together, which is individuals can turn against one another. And if you've been on the FOSS United Telegram groups in the past month, you probably noticed something very similar, which can be a very hard thing to do when you get like a bunch of disparate human beings, you know, into the same sort of space and vying for some kind of ownership and participation and things like that. And there's a lot of drama in the world, and there's no drama like open source drama. So we can talk about licensing stuff that's happened in the past. We can talk about people forking stuff that they should not have been forking. And there's a lot of ways in which the human factors has really played into open source in making it a very tricky place or a tricky thing to work with, which brings me to governance. And the importance of governance is that unless you have a very well-defined manner in the form of charters and code of conduct and all of these things in place, navigating an open source community can be extremely hard. Now, you might wonder if the problem to solving people problems is by bringing in more people. It's by bringing in a little bit of regulation along with more people. So that's what I'm advocating in terms of governance. The last thing I wanted to emphasize is fiscal responsibility. Open source obviously needs money. It's extremely hard to raise money as a commercial company. You've probably heard many stories about that. It's even harder to raise money as an open source foundation and find members. And so fiscal responsibility is something that I would really emphasize if you're working in open source. You really need to focus your very limited resources on things that matter the most. And so it's a very hard situation to find the right things you need to spend money on, to find the right kind of people to support you, be part of the community, be your members, and keep those members interested and sustain the financial contributions from them. So that was my quick take on open source things that are very important if you're starting off on your own on open source projects, or if you're part of larger foundations and things like that. It's definitely stuff that you should hold very central and key to your entire open source effort, but it's definitely things that will really keep you awake at night and make you lose your sleep. Thank you very much for attending the talk. Thank you FOSS United and IndiaFOSS for the opportunity. That's me on socials. Do give me a follow. I'm happy to chat about open source and share opinions on a bunch of other things related to technology. Bye-bye.
Thanks, Ram. Thanks. Okay. Thanks, Ram. Is it not working? I like the emphasis on community and governance, which I am sure are really very important, especially in open source context. And with that wonderful segue, I must announce that our next talk is titled Community Governance of Future Tech. Do we have Vivek?
Thanks, Akshat. Good afternoon, good evening, everyone. I'm Vivek. I am I'm an interested party here. I am, sort of aware of this only in the last few months. I've only been following open source for many years, but it's only in the last few months that I actually got interested in FOSS because somebody referred this community. The reason I actually wanted to come here was because I heard this community has a very strong and committed crowd that is interested in understanding technology, keeping it open source, and more importantly, I think you keep the foundational freedoms in place, and you want to live those foundational freedoms. Thank you. Finally. So I had a couple of points I wanted to talk about in terms of open sourcing, but to carry forward what Ram earlier spoke, right? How do we take Ram's conversation, which he left us with, when it comes to community governance, to the next stage? It's at that point that I think there are a few points I wanted to say, so I'm just going to use my 10 minutes to say that. There is the digital freedom that we talk about, freedom 1, 2, 3, was there on the signs outside. I think the question that I really had to ask was, we are now in the cusp of 2024. We are in that age when we basically can say we have probably given up some of our freedoms to technology, and a lot of freedoms to technology. We've also given it out to the people who actually can build and develop, and they have the power now to take away a lot more freedoms than we usually used to have in the past. So the question is, are we considering those freedoms as sacrosanct, or should we be looking at those freedoms in the context of what development has happened and the exponential improvement in technology that has happened in the last 20 years, 30 years, and 50 years? And these future of freedoms essentially comes to the question of where we stood 100 years ago with respect to freedoms in the modern age, which we sort of try to, let's say, put in place by the establishment of a fourth estate, by the, by community, by media, by organizations that were outside of the typical organizations that you would find. It is here that we decided that we will do this today in through the use of press, academia, etc. They were the watchdogs. In the world today that we are in, who are the new watchdogs, and what are we going to be able to do to keep these watchdogs doing what they need to do? I think it's necessary because this is the age when these freedoms now might be under threat from a new type of, let's say, sentience that might emerge. Now you might be thinking, okay, this is probably a little too fantastical, but I would probably want to just highlight that this is not fantastical. It is a possibility that will happen in the near future, and this is something that would need to be addressed now, because it is the foundation for what we need to build from the day after tomorrow. So the question is then, what would you consider as principles and guardrails that these communities or these groups should be founded on and based on? And it is, these communities and guardrails should be simply based on, let's say, foundational truths, on human truths, truths about human nature that we actually have seen through the test of time. And it should be those ideas that should translate and continue for long. If we are now doing this activity as a group, these aspects should be considered as pivotal, should be considered primal, and it is essentially these, let us say, it's called, it's called sacrosanct, let's say, aspects of who we are and what it is meant to be human. And it is that which we need to bring to the surface and say, if this is the case, then what do we build from here going forward? Now, I wouldn't say that these governance and oversights are easy, but if you are going to do these governance and oversights, and you are going to have to build this in a way that, it is scalable and sustainable, then it should be based on those things which have been proven true for all your life, whether it be about people, about evolution of technology, or about how society and cyclical systems work. So it is essential that we build this technology. It is essential that this technology is necessary for the public good. It is essential that this technology scales, because people and societies, as we know, have reached a point where they have maybe, let's say, crossed the precipice of being able to manage and sustain by themselves without the aid of technology. You could have said that about people, let's say, 100 years ago, but today most society has become too technologically dependent to be able to actually sustain and survive without it. It essentially then means that you need to put in what some of the earlier sessions were about: the safeguards, the the what is that, risk elements, the factoring and understanding all of these different aspects in terms of you know building those what would you call it, hardware, the software, all of that is necessary for you to continue this entire, you know, let's say way of life for most people. But it here, the question really is then all of that is founded by data that is consumed from us. All of that is built by our efforts as developers and as testers and whatever different roles you play. All of that is also done by people who are not necessarily us, but people who are, let's say, in charge of us. So if you are going to do that and let that be the case of most people who are not necessarily you, then you as an individual has already forfeited your right to make that choice in the future. And if you are really thinking about it, what all of this comes down to is your choice to edit and program yourself and the world you live in the way you want to. But if you have given up that already and you've given it up to a, say, a group or a society or whoever it may be, and in the future, if this is going to be taken over by a sentient, let's say, possibility, you are putting yourself in a situation which might be considerably, let's call it, on a path. I might say it's cloudy. You might say it's risky. Somebody else might say that, you know, it's a possibility. And then you have different metrics for it and different ways to analyze all this. Now, I guess what the essential meaning of this is not that I'm trying to say, I want you to posit this versus that. It's not the idea that that is a, you know, that's a bad thing or that today what we're trying to do is wrong. I'm simply trying to give you the probabilistic scenarios of the future and what I believe is possible in the future. It is in this point that we have to understand that all the guardrails and all the, you know, good stuff that will happen from all of these, you know, use cases and all of this work that we do is actually protected, safeguarded, so that we have a good possibility in the future. But at the same time, awareness that this is a risk, awareness that this is something that is maybe the unknown, which you need to be forewarned about or which you need to be alerted about, is maybe a wise thing to do, is all the message that I want to say. It is here that you have to pick your roles. I think the question of what roles we all pick is clear. But then I guess that's where the question comes down to saying, it is here that you need to figure out your purpose. What are you going to be playing as a role while doing this? If you're going to actually play the role as a, may the force be with you, right? May the force be with you for the good or for otherwise. I think that's the whole question. I think, do I have a couple of minutes more? Yep. So, okay, so that's basically what I wanted to cover as a part of my conversation. Now here, the reason I wanted to come to this forum is because I believe a community like this, and I believe a community forum like this, will bring together an eclectic collection of individuals and people from a diverse section of society, stakeholders who come from different races, religions, nationalities, castes, creeds, communities, and across the world, to actually understand what it means that we are here doing this, because we're still talking as people, we're still talking as human. We haven't reached that stage where we have crossed into the next epochs and the future that is to come. And it is at this point that we have the choice we can make. We can decide if we want to be making a choice and where we want to play our roles and how those roles are going to be shaped, because we are going to be the ones shaping that future. And I believe we should be looking at finding it within ourselves what that role should be, what that purpose should be, and play along to that role and purpose accordingly. It's, in another word, you can manifest your destiny through this. I think that would be a nice way to consider it, because you have reached that point where that, let's say, the truth will come out soon. And if that truth is essentially the way it is, I think you might want to be aware that there is a future that you would want to consider, which should be shaped in a harmonious and sustainable way. That's all I wanted to say. Thank you for giving me this forum. Thank you for the opportunity, and I'm grateful that you all heard me. Thank you.
Yep, thank you for this talk. This actually reminded me of, to quote another sci-fi franchise, this reminded me of some of the ideas in Dune, especially like the Butlerian, how the reasons why the future civilization over there abolished all sorts of technology. Yeah. Next up, we also have another lightning talk. This is a change of pace, but this is going to be about from hello world to maintaining a project. Do we have Yash? Yes, thank you so much. All right, until then, we have the next lineup talk called OSI's Open Source AI Definition. We have Tarunima, but do you need a minute? All right, we also have a minute lined up. We also have another lightning talk lined up. We are not short on them. We have FOSS into the grassroots of the country. Do we have? I think we don't. The yes, yes, the infamous issue. We also have a lightning talk titled "Women in Tech" by Nav Gurukul. I think they'll be back in a while. You can have it then. Until then, we have 5 people in the room. Posterity will realize your message. I think we will be waiting for a moment. Until then, let's talk about why would they put the F before the O in FOSS? Because I think it's one of 2 arbitrary choices probably. We had to go with one, and it was easier to pronounce the acronym that way. All right, let's take a quick break. Tarunima, when you're ready, just give us a go ahead. Okay. Let's have a minute to contemplate all the talks we saw today. And we're back. And we are back. We are also back.
So I'm actually here to talk about the open source initiatives.
Boom, boom.
Okay, good. Okay, I'm here to talk about the open source initiatives definition on open source AI. But I wanted to begin, and if the group was a little bigger, I would have actually done a little bit of a pop quiz to first figure out how many of you know about OSI. Do people know about the open source initiative? Okay. And also, how many of you have used AI models in your work? And how many of you think that the models you're using are open source? So how many of you can confidently say that the models that you have used in your pipelines are open source? Well, we can't, and that's in part because we don't have a definition for open source AI. So I actually wanted to start by talking about our own dilemma and why we needed to, why I think it's so important that we all agree on this definition of open source AI. So we have this project called Audi where we were building data sets to train a machine learning model that would detect abuse in Indian languages. And we created this data set that was annotated by activists and experts who speak Hindi, Tamil, and Indian English. And then we fine-tuned Twitter XLM Roberta to detect gendered abuse, and that's deployed as a browser plugin. Now, the plugin is not as important in context of this talk, but what is important is the license under which we were releasing all the different models, right? So all the different aspects of the model. So we have the data set, which currently is released under ODBL. We have the model, so it is hosted on Hugging Face, and with the data, it is open, and the code is also on GitHub. But what we know is that a lot of this data is, the data contains instances of abuse. So there are 3 different data sets. There is one data set that contains instances of abuse. There is another data set that is tweets that have been annotated on whether they are abusive or not. And in future, we expect the data set to expand to images, posts from other platforms other than Twitter. So I'll skip on this. When we were thinking about how we license the data, there are different aspects to think about it. One is that just this idea that the annotation work itself is intensive, and the annotators need to be compensated, and that the annotation reflects a lot of expertise of the annotators. Secondly, one of the other considerations for us is that if the data is being used by platforms for detection of abuse, the fully updated list becomes a way for people to evade moderation, right? So if the slur list is being used by your prominent platforms to detect certain instances of abuse, the people who realize that if the list is open, they'll realize this is how the platforms are moderating, and they will stop using those words and try and use other words. And so that's the other reason why we've been thinking about how do we license data in the future beyond just this bold call of opening everything. So there is this broad spectrum where you have that all data is open for all use cases, whether it's commercial or not, and then the other extreme is all data is closed for all use cases, commercial or not. And then we've been considering whether we sort of open the data sets differentially by time. So maybe older data is not open and newer data is open. And second is we sort of have differential access by purpose, which is that non-commercial uses is open, but commercial uses is not open. And in all of this, the background is that Tattle is an open source organization. All our past work has been open. And so when we start contemplating these different forms of data access, it does bear on how we license our machine learning models as well. So the open source initiative has actually been trying to figure out what this definition of open source AI should be. Just as a refresher, these are the 4 freedoms, right? The freedom to use, study, modify, share. And over the last 1 year, they've been running consultations to understand what that means what that means in the context of AI systems. So this is over the one, they've been iterating on the definitions, and this is where they've gotten to the definition. So they've said that open source AI means that you have open weights, which is that the model weights and parameters are open. The source code used to train the system is open, but the data set or the detailed information about the data used to train the system doesn't. So as far as the data set is concerned, either the data set is open or you just provide detailed information about how a well sort of informed person could recreate that same data set, right? So you don't have to have the data set be open necessarily for your model. It's fine. And the part of the reason why the training data, or they have consideration around training data in OS8, is that there are privacy rules, there are copyright rules, and then there are also issues, so similar to the kind of issues we were facing, there are other issues that certain groups might not. So indigenous groups, very famously, there's a group in New Zealand that's been creating its own data sets from the community. They don't want to open their data to bigger platforms. And so there are a lot of reasons why people might not want to open the data sets. But if they provide adequate information on how to recreate this data set, OSI will consider that the model is open. So the devil is in the detail, in that it depends on how much information about the data set counts as sufficient information. But it's also, like something that is not a clause that everyone is very comfortable with. So what I do want to conclude with is to say that if you have an opinion on this process, and because the OSI process is influential, you should go on the OSI website and leave feedback on this definition and what you feel about opening the weights or opening the code, as well as their current existing specifications around opening data, or not necessarily opening data, but providing details for it. That is the end of this talk. Thanks.
Thank you. Thanks for that talk. I will now have the pleasure to invite our next speaker and the next talk, From Hello World to Maintaining a Project by Yash. I may have to hold on to that pleasure for a while, and I'll go on to the next talk, which is FOSS into the grassroots of the country. We will have to wait a while, I guess, to see that talk. I think, would anyone present want to speak about something? I saw this. Yep, we don't have people from Navgarugul. It's cool. All right. I guess then we can wind up. I could give a short talk on depictions of FOSS in fiction, but I think it could turn out to be very chaotic. So I'd rather we wind up and enjoy the rest of the event. Audi 1 is still going on, evidently. So thank you so much, everyone, for coming on.